Andrea Fink, who also accommodated us. Now, because of that change in date, he has to be in Leeds, in the UK. That means he has been in transition. He still accepted to talk, even while in transition. So we want to appreciate our dear friend, who's been a partner for a long time. That is Professor Andreas H. Fink, a professor of tropical meteorology. And the interesting thing about it is that you think that because we are in Africa, because we are in tropics, we know it all. That's not true. The truth of the matter is that there's so much research going on. There's so much research going on in other parts of the world who love Africa, who love tropical regions. So today we have Professor Andreas H. Fink, and he's from the Castro Institute of Technology, KIT. We're talking here about Institute of Meteorology and Climate Research, Tropospheric Research Group, MICRO, in Germany. But right now he's in Leeds, and but he's still talking to us. So we want to thank him because he's going to talk on a very important topic, which is new AI and data-driven methods for better precipitation forecast in Africa. We have been collaborating with Professor Fink, and it's quite interesting. He has even trained some of WASCAL students. And I'm happy here today to say that this is synergy between WASCAL and KIT. And that is why I would want Professor Kone to also welcome Professor Andreas Fink, who has been a collaborator. Please, I want us to focus at the camera in Professor Kone, so that he can also say some few words and welcome Professor Andreas H. Fink all the way from the United Kingdom. Thank you, sir. Over to you, sir, Professor Dada Kone.
Hey, good morning. Good morning, everyone. Thank you for being here this morning. Servicing first to the time. Good morning.
Good morning.
With Andreas Smith. Good morning. Maybe I'm not receiving your feedback. I know you are speaking. It's not working. Okay, thank you. Thank you very much for having the time and also your availability to be with us this morning. We really appreciate your commitment to WASCAL. A long years ago, you have been with WASCAL. You are still with WASCAL to do academic and research activities. So we are grateful for that on behalf of the Executive Director. I want to welcome you on this platform to share with meteorologists in Nigeria and also students of WASCAL and professional also what is about the topic we will talk today. We are really grateful for your time. And then we know also we continue this collaboration. I'm sure for this current batch going on, you have already identified some students who can work with you. And through also the project like CS for RRA, I know also you are working also for the researcher at the Competence Center to have some solution. Please, warm welcome to you here from Lagos. We appreciate again your time. Please, a round of applause for him. So I give back the floor to you, Prof. Debo? Now, LOC? Start?
Yes.
Yeah.
You will share screen.
So now you can start.
Okay.
Share screen.
Okay, you can see.
Yeah, that's great.
So can you see the screen? Can you hear me and see the slide? Can I ask if you can hear me and see the slide? I would.
You have the floor, but we are not hearing IT. Is something not going well? The sound is not.
Okay, so I share again.
Cannot hear.
Oh,
It's on my own mic.
Yes, bro. We can see and hear you online. Loud and clear.
Okay, you see the slides, right?
Yes, bro. Yeah.
where should be the problem?
Please tell me when I should start.
Oh, you don't have to see the problem now. No. Please, can you try and speak so we can see whether we can hear you?
Yes, I hope you can hear me. And
Okay, yeah, we can hear you now.
Yes, this is fine.
okay, then I take the liberty to start, and please interrupt me in case of technical issues. So first of all, thank you very much, Professor Debo Adeyava. Thank you very much, Professor Dauda Kone, for the warm welcome. And I don't know if there are other good friends from Nigeria in the room, like Professor Motosho or Professor Balogun. So I'm quite honored to give the talk today to you. And as mentioned, we have worked together in the past and within the next cohort of WASCAL and maybe other projects. I'm really, really keen to continue the successful collaboration with Nigerian colleagues. So you see here the slides, and I have to acknowledge contributions here from Peter Knippertz to this. So I give you a summary of research that we did here at KIT in recent years on these new AI and data-driven methods for improved precipitation forecasting in Africa. So this is the content. So I will motivate the work. And then, we should not forget actually how good could tropical rainfall forecast be in a theoretical sense. So there are theoretical limits of predictability, which we can likely not cross with conventional models or with AI models. Then, of course, the question is how good are the models today, mostly the numerical models, and they have by far not reached the theoretical limit of predictability. And therefore, the question, how can they be improved? And I will give some methods of improvements like statistical post-processing. What is the value of better observations and data assimilations? Some people think we can improve precipitation forecasting by convection permitting resolution, but I will show that this is limited. What about better numerical models? And then in the end, I come to machine learning and data-driven models, and I end with a conclusion. Okay, let me start with the motivation here. Why care about tropical rainfall predictions? You know it quite well. So an increasing fraction of the world's population lives in the tropics. Here you can see that in East Asia, for example, in Africa, and in parts of South America. Oops, I have an issue here, sorry. This proportion is increasing, especially in Africa, and the population is vulnerable to strong precipitation extremes. So in theory, if we have reliable rainfall forecasts, they could support decision-making in the various sectors that I have listed here. But there are challenges, and this is a paper that we produced with Benjamin Lemke, which summarizes some of the challenges, but also ways forward for weather forecasting in Africa. Some of it I will explain today. So now, how good could tropical rainfall forecast be? So imagine we would have a perfect model with perfect initial conditions. And there is a paper by my colleague Falco Jut from ENCA. And what he did is he did so-called identical twin experiment with a convection permitting model. In his case, it was the MPAS model. And what you see here is two panels. On the x-axis, it's the wavelength, so it's a spatial scale here. And on the y-axis, you see the days, and orange indicates a 60% error saturation, red, a 90% based on the so-called disturbance kinetic energy. So what you are doing is you are integrating the model for a couple of days with just a tiny difference in the initial condition, in the perfect initial condition, and you evaluate by the kinetic energy here how the spread increases over the integration days. And you can just basically say orange gives a useful limit in terms of predictability with 60% error saturation. So when you look into the left, it's the tropics. And if you look on the right-hand side, the mid-latitudes, you see in the orange curve at wavelengths lower than 10 to the power of 2, on the that the predictability in the tropics is much lower than in latitudes below, say, 300-kilometer wavelengths. This is because of convection, turbulence, and so we theoretically lose predictability quite early at these time scales, spatial scales in the tropics. But when you go to higher wavelengths, so 10 to the power of 4 kilometers, for example, planetary waves, then you see on the left-hand side, especially in the top where we have the stars in the orange color, that you can have predictability in the tropics up to 20 days, which we don't reach in mid-latitudes. So the basic message of this way of finding the intrinsic theoretical limits of predictability are at higher spatial scales. The tropics have a lower predictability, but due to the tropical planetary waves, they have a higher predictability of 3 weeks or more at the larger scale. So this is also from this paper from Falco Jut. It's looking at a Kelvin wave. Kelvin wave is one of the waves that belong to the equatorial wave, natural eigenmutes of the tropical atmosphere and ocean. You may all have heard it. And you see here in this planetary feature that the error grows very slowly. Look at the right-hand panel. Look at the red curve. Look at the normalized error. And it grows slowly, and it's still far from being at saturation at day 17. So saturation would be if the normalized error would reach 1. There is a decrease at day 20, which is a filter artifact. So the decrease of the error beyond day 17, we should disregard for the moment. On the left-hand side, of course, you see an example longitude in the x-axis, and you see the days of such a Kelvin wave error growth. But again, the point is we have some predictability for the planetary features in the tropics. Other features are, as you know, equatorial Rossby waves, mixed gravity Rossby waves, inertial gravity waves. So these, could give us, like also the Mendelian oscillation, some predictability at the larger scale for days up to 20 or more. Yeah. And of course, they can couple with convection. And the question, for example, would be if we use this predictability, if we train an AI model, or if we use it in a statistical forecasting method, maybe then we get back some predictability on smaller scales. There are also African easterly waves, which are more baroclinic features, which could also, be used in this regard. And this is, from a paper that Peter Knippertz and we did. So it's, the identification of equatorial waves in, using different methods here. You see here the Kelvin waves, and these are the methods. We have one problem in this, that the waves, to identify them is even an art of itself. So depending on the method you use, you get, these different pictures of Kelvin waves. Okay, take-home message is predictability is generally larger in the tropics than in mid-latitudes. These holds even for current initial conditions. So the, paper by Falke was on perfect, but we are not far from being perfect in initial conditions, but still the same statement holds. At the, high, at the, high special scales, at a few kilometers, 100 kilometers, errors in the tropics theoretically grow fast, but slowly at planetary scales. And a long predictability seems to be related to these equatorial waves. Yeah. And what it means is that local to regional forecast should always be probabilistic because the predictability is low. We need a lot of members to assess uncertainty. And this is something I come back to later when I come to AI. So how good are numerical weather forecasts today? This is here a paper by Hayden from ECMWF. The SEEPS score is a score that measures quality of precipitation forecast. Basically, the higher, the better, different models. And this is for the tropics, and this is for the extratropics. And look here, the scale is different. So the tropics we reach at day 1, a little less than 0.3, whereas in the mid-latitudes we have, almost 0.6. Yeah, that means, we have much lower skill in the tropics for precipitation forecast out to 6 days. And this red curve, what it shows is that actually in the extratropics for day 6, we have a skill that we barely reach in the tropics for day 1. So one statement is here, we have a skill in precipitation forecast in mid-latitudes up to day 6 that equals the skill in the tropics, for day 1. So much harder to predict. And this is the work that we did at KIT here. So that's the ECMWF ensemble forecast for the prediction of the occurrence of rainy days. So the threshold was 0.2. And what you use is a Breyer score. Here we have the so-called Breyer skill score. So you evaluate the forecast against a simple trivial forecast. So the simple trivial ensemble forecast was from climatology from observed TRIM or GPM IMERGE rainfall. And, blue means that the ECMWF is better than this trivial forecast for the next 24 hours. And red means it's worse. And, when you look onto the tropical continents, especially Africa, a picture emerges, especially here in equatorial Africa and in parts of West Africa. The 24-hour ensemble forecast of does it rain on the next day or not is worse than a simple forecast for this part of Africa. It's better, more in the off equatorial regions, but we have these big problems over tropical Africa in predicting the rainfall occurrence of the next day. Okay, so this is then another score. It's called the Continuous Rank Probability Skill Score. And this score is a proper skill score to really forecast the precipitation amount. Again, the trivial forecast is coming from the TRIM. At that time, we used TRIM. The skill is measured against this climatology, which we describe in Walz et al. And you see, especially again here over large parts of tropical Africa, the trivial forecast from the climatology is better than the ECMWF forecast, at least from the model version that we took in the paper of Vogel et al. Now we look into more extreme forecasts. So this is the Breyer skill score of a one-day forecast of 20 millimeters per day. The gray areas mean there are dry regions in which this does not happen. Yeah. And you see again, negative skill in tropical Africa, whereas other regions like the Maritime Continent, India, Northern Australia show some skill. So your region is really standing out as, the region which, it is hardest to predict the rainfall of the next day. So the take-home message here is local rainfall predictions in the tropics by operational models are really poor and much worse than in mid-latitudes. Yeah, this holds for high-resolution deterministic as well as for low-resolution ensemble forecast. Errors are largest in the occurrence, but for amount and extremes, it's also low. And tropical Africa is really standing out as having a particularly low skill, even worse than climatological forecast. And it's a little bit surprising because I mentioned that at the longer time scales, we have these long intrinsic probability from the waves. Now I would like to move on to how can these precipitation forecasts be improved. There's a method, it's called statistical post-processing. So let me, say that this corrects systematic deficiencies in the models. You need to look at the forecast of a model of the last 20 years, and then you can really improve biases and also correcting for so-called under or over dispersion. That means that the PDF of the forecast is either too narrow or too broad. So you can do this. You learn from, correction function from past forecasts and apply that to the, recent forecast. And there are also now many new approaches based on machine learning. Here, I'm not showing the results for machine learning yet. So we use some classical methods here as described by Gneiting et al., EMOS, and this is based on the generalized, extreme value distribution. Yeah. EMOS stands for Ensemble Model Output here. And you see, when we do this here, this is the raw forecast of the precipitation of the next day, and I'm skipping to the next slide, post-processed. You see, we can get rid of almost all red area, which means we improve the forecast, but have a look to Africa. It's going from red to white, which means post-processing, just allows us to improve the skill from, being worse than the simple forecast to be equal the simple climatological forecast. But we can, improve the skill and at least get neutral skill over tropical Africa. This is now for the same sample that I showed before, the forecast of 20 millimeters or more for the next days. Does it occur, yes or no? Then we see here these, red things. Well, we can get to, white. There's a little bit of skill appearing here in Eastern Africa on this. But again, post-processing is, improving, but it's not changing the world for the forecast of next 24-hour rainfall in tropical Africa. So what about better observation and data assimilation? As you know, I mean, this is an old map, but it would, from last year show the same. In the tropics, especially in Africa, there are few radiosondes. And in other areas, I mean, there are much more. But we have a problem in the tropics, whereas in mid-latitudes, we have geostrophic balance. I mean, we don't have that in the tropics, and so lack, of geostrophic balance requires mass and wind measurements to constrain the additional conditions. But as you know, it's a financial, technical, and logistical challenge. What could we gain from more observations? And here's one study that we did when we had a field campaign 2016 from Dakiwa, with participation, by the way, from a colleague from Nigeria, from Ile-Ife. And we did a so-called data denial experiment, and we assessed, with and without the sons, what is the improvement in rainfall. And you see here the stations where we did additional soundings here. As you see, Nigeria is involved. So it was more than 900. But, with sounds minus without sound, you see a very patchy signal. So the 900 sons, which cost a lot of money, I mean, the impact on the 24-hour rainfall improvement was marginal. The reason I will highlight, again in the summary, is that data assimilation and models are quite poor, so they cannot carry on the benefit of additional observations for more than 24 hours, and for a very noisy variable like rainfall, even, barely they can do that for 24 hours. So this is another experiment that Peter did here with Maurus Born. So there was a so-called Aeolus satellite in orbit for 2-3 years. And this is now here the improvement here you see here in percent, of the RMSA reduction when you use these additional observations from wind based on Aeolus satellite. And you see here, this is 24 hours, 48 hours, 72 hours here. This is here the tropical belt here. And you see there is a benefit. Interestingly here, from the DWD model here, there is the largest benefit. which means in the sense ECMWF model versions, they were already quite good. So from the additional measurements, they, benefited less than the DWD model. But again, the data assimilation, which is quite a problem in the tropics due to the lacking geostrophic balance and the poor representation of the model convection in the models, limits the impact of better observations. Yes, of course, you can do convection permitting resolution. Here is a paper also by our institute here from Gregor Pante and Peter Knippertz. And you, of course, see that you improve propagation of convective system, that you improve the diurnal cycle here with respect to trim. But the question is, with these better propagation, with these better diurnal cycles, do I also get better forecast? And this, as you will see in this following slide, is questionable. There's, for example, here, if you use explicit trim, you have a reduction in the, bias here over the Sahel, but you obtain more problems here in the coastal area. And another example is here from Becker et al. They used the ECMWF model in a convection permitting mode, but also using a new parameterization scheme here, including advective moisture intensity. And when you see here the explicit versus here, the new scheme, you see here I have a nice, score line, whereas the explicit has too intense and too localized here convection. And in another paper that we are currently preparing here is we show in terms of the Breyer score for the next day. So does it rain or not, or for the amount, where is the convection permitting French a Rome model or UK TAM model better than the operational, ECMWF forecast? And you see here, there is an improvement here in these brown areas of occurrence, but not so much and clearly for amount. So basically, neither post-processing nor more observations nor convection permitting models are really a game changer here. Yeah. Okay. So better numerical models, would they help? I mean, this is a study here that we also did at KIT. So basically, the question is which range we should give certain model parameters in parameterizations like entrainment rate to bring about a more realistic rain belt over Western tropical Africa. The model has so many parameters, you cannot, integrate it with all possible combinations. So there is one method where you run few selected simulations and, construct a so-called statistical surrogate model. And then you can, of course, look at cloud cover, water vapor, the 2-meter temperature, the latitude of the rain belt and pressure. And you can ask yourself, to which parameter actually, the model reacts most sensitive. I won't go deeply into this, but, this is, one result to get an optimal, let's say, here, precipitation per month here. Yeah, you see here the solid line is from the icon model. Here, the dashed line is from era 5 and observational here reference. So what it says here, if you do multi-parameter optimization with the largest weight on precipitation fields, you really arrive at solutions here in the model, yeah, which are not, located at where the observations are. So what this is saying in principle, you really, cannot get an optimized solution that fits all, parameterizations or parameters that fits all solutions. Yeah. Okay, now I'm arriving at the machine learning improvement. So we did some studies here comparing a lot of models. I come to this later. And what is actually doing the best? So this is, again, the so-called continuous rank probability skill score for a one-day forecast of rainfall amount for the period June, August, September 2011 to 2019. And you see here, this is a numerical weather prediction model with post-processing. And you see here that against the trivial forecast, you are barely better than that. If we use statistical forecasting, using 25 predictors from past rainfall observations, we are actually reaching similar values when compared to the numerical model. And statistical models are much computationally cheaper. In the machine learning approach, where we used actually a training or model trained on GPM iMerge rainfall, you really see much bluer colors against the reference forecast. I come to this later again, and you see how much we can improve. CNN is a convolutional neural network, and I will explain EasyEQ in a minute. But the basic message here is the costly numerical model can, I would say not be beaten, but you can reach similar skills when you do statistical forecasting based on past observations. And when you do machine learning, you can really, really improve the forecast. And it's very cheap. So there are several magnitudes of orders less computational cost when once the machine learning model is trained. This is another study that we recently published. We used machine learning, but also a classical gamma regression forecasting approach. And what we actually did is we used observed parameters of tropical waves, like African easterly waves, like Kelvin waves. So for example, what was their location and magnitude at 0 UTC, and from this we used this information in a gamma regression and CNN approach here to forecast rainfall. Yeah. And you see here the machine learning forecast really outperform the operational ensemble. Here is the scale. It's a CRPSS. Blue colors mean it's an improvement. And you see here really in the blue, but also with the gamma regression that we improved. One point that I wanted to say also in the next is in this paper by Walz et al., we used CNN to do a deterministic forecast, and we then used also a data-driven method to make an ensemble out of this deterministic forecast. And this is basically a summary of these very, very, let's say, complete study here. So we had different forecast models like climatology here, physical-based methods here from ECMWF, for example. There are statistical methods here, and there are the machine learning methods. And we also had ones, we called it hybrid, where we weighted the machine learning and the numerical by half. And have a look into these two panels here. BS is the Breyer score. So the lower here the score is, the better for June, August, September of 10 years. And the lowest here, if you look here, that's the CNN model, which we made ensemble by ECUQ, and the hybrid model. And EPS is the raw, you can see it here, ensemble forecast from the ECMWF. The ensemble forecast improved over the years, the 10 years here. As you see here, it's getting lower, but it's way worse than the machine learning. And even with some, statistical forecasting here, that's for the Breyer score. We use the logit model. There's a different model for the amount here. But if you look here to the logit base and logit full, we are in this range. So we are much better here than the raw forecast. Of course, we can do post-processing with the raw forecast. The post-processing is the black solid curve here. But for precipitation occurrence, really, we are several percent better improvement in the Breyer score. And this is for the continuous ranked probability skill score, and the lower the better. And you again see how well the CNN and the so-called hybrid model, where we merge classical forecasts with the CNN model, is. So really the take-home message here is for the statistical post-processing removes systematic deficiencies, but skills are hardly better than climatology in tropical Africa. I showed to you impact of additional observations, positive but limited by the model error. We have low predictability and assimilation technique, particular with respect to rainfall. Explicit convection is not necessarily superior to parameterizations in any respect. It's, maybe better to spend the computer power on the AI models. And this study where we said, if you want to get a good representation with the model, how do I have to set the different model parameters? There is not a good solution, one fits all. So it's really hard to optimize these models. And in this context, machine learning really approaches, are very good in improving the forecast. And once trained, they are a really cheap alternative to numerical weather prediction models. The conclusions here, we know that reliable rainfall forecasts could have enormous socioeconomic benefits for tropical Africa. The high intrinsic predictability at large scales, I should better say we have low predictability at convective scale, but high at larger scale. But we need well-calibrated ensemble. The low predictability means you need a lot of ensemble members. And once trained, these AI models, can create 1,000 ensemble members for the next day forecast. Whereas, ECMWF is currently doing 50 or 100 for the ensemble. That, is a lot of computing power. We have, of course, the issue of poor initial conditions, model error, and ensemble miscalibration here. And here are, the ways of improving it. Post-processing, it's cheap and robust, but has some limitations. Post-processing nowadays is also done using AI methods. We can do better observations. They are expensive, but the benefits are limited by the model error. high resolution for forecasting, it's expensive. Benefits are not conclusive. Better models are hard to realize. And yeah, so the solution is really the machine learning approach. It's an economic compromise with remarkable performance. With this, I would like to conclude, and I'm happy to receive questions. Thank you very much. I cannot hear.
I cannot hear.
I still can.
Oh, you can see, you can hear me now because.
Yes, I can.
All right. What an interesting presentation, because this is the high end. There are forecasters here, there are students here, there are professional people here, and this is a great time. We immediately had some challenges listening to you, but later it's better. But at the time, I was oh my God. At the time, I was tempted to say, can you go back to the motivation where you started? So this is a very wonderful thing because it took us through to see what like skills. Tropical regions are better, but when you have convective systems, in tropical regions, things are not as good. In fact, the bad news for me is that even when you improve your observation networks, it doesn't still improve. But thank God for machine learning, and you can see the CNN, combine it with flights and so on, you get a better result. It's economical. So machine learning is the way forward. That's quite great. Now, I'm sure you are taking notes in spite of our challenges, and you have questions. So how many of us have questions? Raise your hand up. So you come forward and ask your questions. This is an interesting question that I wish that NMetS. Sir, you are here, sir. You can see society can actually bring up skills so that we can collaborate and NMetS to improve, because machine learning is the way. Even increase our S everywhere, we are seeing that it doesn't really sound. We have Lagos, Mina, and now where they so proof them is not really going to happen very well, because when he has 4 lines, not really good for them. So yes, I those NMetS to come forward and ask questions. And I do hope that our friend is hearing us very well. So the first one, so we have one here. Who else? Emmanuel Aweda has a question. Yes, then you have a question. Ask our questions now. A time will come when we decide we organize so that we have a convergence. And Andreas is hearing me now. A convergence is necessary. For us to leapfrog, we need a convergence. And thank God what Carl is here, that he may have to come here. He has been collaborating with us. And this is the high end. So shall we have you, please? And can we focus? Yes, we go online, but let's deal with those of us who are here physically. Let's focus. Let the machine train on him as he asks this question.
I see it's focused on it.
So good morning, professors. Thank you very much for the insightful paper. My name is Maxwell Isioro. I'm from NMetS. I'm an instructor with the Regional Training Center at Oshodi. I have a background in machine learning and big data. So I want to ask you, it's obvious that NWP models are quite expensive to run in the long run, and machine learning is the cheaper alternative. You have enumerated the advantages of machine learning, but I would like to know which particular machine learning model. We have several types. We have XGBoost, we have random forest, we have the neural networks. So which of the machine learning models did you or do you think is better for tropical forest?
We will have taken all the questions, but I want to be sure that he's hearing us and we can hear him. So we want Andreas to please answer this one. That will be a training model for our machine learning. So we know that we can go on with other ones. Andreas, please come.
Yeah, so thank you for the question. So I have here that in terms of the method to be used, you mentioned random forest. I cannot give a definite answer. So we did all this research with mathematicians at KIT. And what I can say, though, is that, with these, let's say, data-driven forecasts, we did not use the random forest approach. I can't remember what Eva Maria Walz used in her approach. So then, of course, maybe there are these so-called large language models, as you know. So the AIFS is a good example from the European Center. And personally, I think the more relevant thing is how you define the cost function, the so-called cost functions, to which you optimize it. ECMWF has, in an earlier version, used a diffusion approach, but recently they have trained their, AI model to optimize these CRPS, these continuous ranked probability skill score. So I think you have to really think against which cost function you optimize. Another issue with the AI models is they are often trained in the past to optimize the so-called root mean square error. What it has caused, if you look into AIFI's model forecast in the past, is that the rainfall fields, for example, were way too smooth. Yeah, because they were optimizing RSME. So my take on your question is, I'm not an expert in all these detailed, techniques to do the machine learning. I think it's important to think about against which you want to optimize your model. And here, my suggestion is to use for the large language models really, metrics, skill scores that we use in meteorology. That is one recommendation here. And, there is another, sorry for this long answer, but there's another aspect here. I told you that AIFS forecast or machine learning forecast of rainfall are often too smooth. So they have a, let's say, other effective resolution than the numerical models. And in order to compare them, you also need to do a fair comparison. Yeah. So whereas AI models are very good, you need to compare them in a fair manner to the numerical models, and they also need to be post-processed. So in my, again, statement is here, the technique, you might try out a few techniques, but cost functions and later look at efficient resolutions and comparisons. That is my focus on it. Sorry for not giving a more technical answer on this.
Thank you very much. Andreas, there is, you have a, it's have to come up, and then we want to see your face. Please be careful because our setup here is so delicate.
Yes.
Your name, where you come from? What's that? What's the term?
Thank you, Prof. My name is Yugda Dama. I'm from Burkina Faso, but I'm a student of FUDA, WASCAL program. My question is about the impact of data availability in West Africa and this machine learning model that for West Africa. How much can we speak about the impact of this data quality? Because machine learning needs a lot of data and quality data, but we know these challenges about data. Thank you.
Okay, after this, we'll harmonize all the questions and answer them. Now that we see that you can hear us, please go ahead and address.
Yeah, I am not sure that I got the question because of some, issues with with the noise here. So you are asking about impact of data, especially, when it comes to machine learning, data availability. Is that right? I didn't get it. Maybe you can quickly answer your give your question again.
Okay, I'll come back a little bit on it. It's the challenges that you have in training this machine learning due to data availability and data quality in West Africa.
Yeah. Okay. So let me try to answer your question. You are absolutely right that the lack of availability of data in Africa is an obstacle to the application of machine learning models. I give you one example. The example, of course, that you all know is precipitation. So the precipitation that we used in our machine learning approaches comes from the GPM-IMerge satellite. And if you know, of course, GPM-IMerge is good, but it has, errors, it has problems in some regions. And I have no solution to this problem that you don't have a good, training data set for the forecast. What I think you could do, and I'm talking, for example, about NMetS. Let's just have some guesses. For example, if NMetS could, maybe they do already, use post-processing approaches, AI-based post-processing approaches. They can use their data from the stations to calibrate the forecast, from either an AI model or a numerical model for the station. So I think for this, the data that the weather services have might be sufficient. But what is not, in my view, an option is that you have enough rainfall data from the surface to really train, let's say, a sort of a large language model with these data. So yes, data availability is a problem, but AI, applications like in post-processing of the forecast, calibrating the forecast, say for Lagos, they can use the data. And of course, I can say as a scientist, it would be good if the data would be available for research in this regard. Thank you very much.
Thank you very much. There are some online questions. I want us to finish up here. Then we go online. Now, do we have any more questions for those of us who are physically here? Yes, Dr. Manuel Weda should come forward. And then, you have, all right, after him. Because now we want to take the questions together and then he will answer at once.
Thank you so much, Bob, for session. Okay, thank you for this informative session. And yes, our system, our terrain is highly heterogeneous, which is why it's
difficult, but it's possible. It may take some more time, especially with the advancement of technologies. So my name is Emmanuel, and I'm from the Regional Training Center of the Nigerian Travel Agency. So we are more of capacity building and training of upcoming weather observers and forecasters. And now that we're in the advent of machine learning and the applications of artificial intelligence, my little bit of concern is in the development of competencies and capacity building. We have some of our students right here, and I'm sure that they would like to know what are the basic requirements, starting from scratch, so as to develop their capacity in knowing how to apply machine learning and artificial intelligence techniques to both observation, forecasting, and predictions. Thank you.
Okay.
Go and answer the question before the next
Yeah. So
one. Please go on.
So Debo, there were two questions in the chat.
Yeah, but please ask the last question.
Yeah.
The last one, we come back to that later on.
Yeah. So maybe there was one question regarding slide 38, where I was asked to clarify what components were used.
Andreas, did you hear the last question? Did you hear what he said in the last question?
Yeah, I'm sorry, I'm not sure if this was a comment or a question. So maybe I didn't get the question. Sorry.
Okay, he will come back. We want you to answer the question, then we go back to the online questions. Please, you have to come back. You have to come back. He didn't actually get you. That's why you need to speak louder, clearer. Please.
All right, Prof, can you hear me now?
Yes.
Okay, so my question is about development of capacities and competencies, capacity building and competencies. I'm from the training unit of the Nigerian Military Agency, and due to the current discussions that we're having right now, it's very, very important that we take this information back to those we are training, the upcoming observers, weather observers, and forecasters and climate scientists. So my question was about capacity building, the requirements for capacity building and development of competencies, because at the end of the day, we are grooming the next generation that will enhance the quality of our observations, forecasting, and predictions. So my question is basically about competencies, development of competencies, and capacity buildings. These are these basic requirements and the things that we need to put in place. Thank you.
Okay. Sorry for now I got it. Yeah. The answer here is, of course, we all agree that there is capacity building needed. I mean, Africa has a lot of young, very talented researchers also in the field of machine learning. I can just say, for example, that if you go to ECMWF web page, they are currently offering and developing, we are involved in that, a new massive online open course in machine learning methods in forecasting. So this is certainly an option, but I'm looking also into Africa, and we are having a connection to colleagues from Ames, Rwanda, for example, to Bambasila, and they are also trying to improve capacity building. I can also say it's not yet open that, for example, the German government wants to fund an AI competence center in East Africa, not in West Africa. So there's a lot of things going on, but I think there is still this old problem of bringing the capacity building to the forecasters. I'm not aware of what WMO is doing here. I just say, use these options like ECMWF with this massive online open course is taking now. ECMWF has a so-called SEVA program, Forecast in the Box, that should help, young Africans in improving in machine learning methods in weather forecasting. It's a big point, but I cannot give really a good answer to this. So it must come from both sides. Stay informed, and also, of course, young researchers in Africa within the WASCAL project should be trained in AI methods, which we do with the new cohort. We have a much larger focus on AI methods. It's not a good answer, but yeah, I have tried.
Thank you very much. Yes, you really tried. I think Professor Peter Jugo, Professor Kone, all those who are dealing with training will look at what we can do so that we can bring up these young ones. Before we go online, please, we have a lady who also wants to ask a question. So, your name,
Thank you so much for your presentation. My name is Regina from Senegal. I am WASCAL student in Futa. So I have a question. It has been shown that tropical waves like MGO, African Eastern wave, those waves in tropical, they lead rainfall variability in Africa, or let's say in tropical area. Now, my question is, are they well represented in whether in numerical model prediction? If not, what is the difficulty? Thank you.
Okay, that is actually an excellent question, which I can also not fully answer. So in the numerical models, we know, for example, the ECMWF model has skill for the so-called RMM. This is a score for the MJO up to week 4 or even 5 on the global scale. When it comes to Kelvin wave, unfortunately, the skill is relatively fastly deteriorating in the model up to a week or maybe 2. At the moment, I don't know the answer how well these waves are represented in the AI forecast. I mean, there are programs currently running, and we do that at KIT. We also want to look at the AI models. How well do they represent, meteorological features like waves? So far, I cannot give you an answer if they better represent the waves or if they, represent the waves more poorly. But saying that, there are approaches published, and we used it for the 24-hour forecast, where you use the waves, in numerical models, the forecast of the waves, and put this as predictors into a statistical model. And that can improve rainfall forecasting for week 3 and 4 in the so-called subseasonal range. So the answer is MGO, for example, is quite well represented. When it comes to Kelvin wave or mixed gravity Rossby waves, that is poorer. So it depends, and it's not yet clear to me at the moment how well these waves are forecasted in the AI models. The point is, the current AI models I'm aware of only do forecast until day 10 or 14 and not for 6 weeks.
Okay, thank you very much, Andres. We now go online. We have 5 questions. We have 5 questions online, and I would want you to take them together. This question is from Stephen Ogunkwero, and he's asking about on slide 38, whether you could clarify the components where we have combined or hybrid system. Then the other one is asking if NMetS, from strategic point of view, could have a current capabilities of machine learning and development able to support this. And you will answer. We need more answers from NMetS themselves, because there's another question from Peace Awole from South Africa. He's asking that could it be that CPMS are not less predictable per se, or simply exposed to deficiencies in initial conditions, more clearly due to their sensitivity to small-scale processes. And there's somebody online also, it's Dr. Donatos. It's asking, it's actually appreciating your presentation, and he wants to ask how you will integrate quantitative and qualitative data using machine learning to come up with the results, the forecast. And finally, we have Stephen Ogungwenro is asking about recent advances in AI learning that go beyond reliance on static training data sets incorporated and so on. So anyway, there is another question. It says, will it be that CPMS are not less predictable? Okay, ask that question. So please, you take these questions that since you have access to. Thank you.
Okay, so I try. I and maybe I can't. So regarding the hybrid system on slide 38. So here, hybrid was meant in a sense, we combine numerical forecast with AI methods. And our hybrid model in this regard was simply giving the forecast of the numerical model, which has been calibrated, the same weight, let's say 0.5, than the CNN model. So that was our simple hybrid system, yeah, in slide 38. So then was the question regarding, may ask if NMetS, could support our, if the machine learning could support our current operational forecasting activities. My clear answer is yes, of course. One option would be to download the free AIFS forecast from ECMWF and checking their skill. Another potential thing is you would take a model like Pangu or others and just run it on your computers with initial conditions from ECMWF. That is another thing. So it's possible, but of course, it always comes with some efforts. But in principle, yes, you could do that. That is my personal opinion. Yeah. Then there was a question here. I want to ask how one would integrate quantitative and qualitative data using this machine learning to come up with results of a forecast. I'll be honest, I don't know what is meant here with qualitative data. I'm talking about quantitative data here. It's a little hard to me to understand the context of the question, but I'm also referring back to the NMetS question before. For example, if there is a pre-trained machine learning model that you could take to NMetS, of course, it can be used with quantitative data for NMetS example for refinement. So I do see also an option for the weather services to take, these trained data and do a retraining, which is not so time consuming than the initial training. Okay, then there was a question about the CPM models, that they are more clearly, expose the sensitivity to small scale processes. Yeah, but I don't think that even the convective permitting model represent the error growth correctly. So I would not say a yes to this question here. Yeah. Okay. Then there was a question on the computational resources. I think one big problem, in my view, is to train a AI model, especially a large language model. You would need to use huge GPU clusters. That is a problem. But I know that Google or NVIDIA sometimes would grant you access to their, clusters here. That is a way maybe of doing it. Other than that, training the model is a big computational effort, and this is, in my opinion, a bottleneck for application of machine learning models in Africa. Yeah, and hopefully there are options of using cloud computing infrastructures here. I know that there's projects in which Google and NVIDIA has granted, time to African researchers in this regard. So let me see what I have not. So regarding data assimilation, there was one here by incorporating new observations during the development process. I cannot answer this question because I'm not an expert in this. Okay, I'm checking other. I don't see anything.
Okay, I think that's about if as many as possible. That's quite great. Thank you. Right. Thank you very much, Andreas. What you have done is fantastic. You have taken us through the motivation, taken us through the models. You've taken us through the different types, the physical-based, statistical, and the machine learning, of course, the hybrid. And you have told us how complex the critical regions are when it comes to competitive systems, which we need because they create the flood and other things. But we need to do a lot more of this. And that is why we are very, very grateful. We're going to call on Professor Kone to say thank you. Finally, we have somebody in our midst who is the Director of Research and Training for NMetS, and he's here. It's been nice that we hear from him because somebody is asking.
Somebody's asking. Okay, we'll do it. That working?
Somebody's asking
for the capabilities
and preparedness of NMetS for what we're talking about. And it's good that we have him in the house. Let's welcome Professor Peter Ojugo. Thank you.
Yeah, the presenter, thank you very much. I'm happy about your sincerity in answering most of the questions. One you are conversant with, very clear, conversant with that. The other one, that is the spirit of academics. Yeah, in terms of what NMetS is doing and in terms of capacity and competence. Yes, NMetS, the current DG of NMetS is an ICT client, and since last year, NMetS has been trying on how to go deep into the AI in forecasting. So early last year, some of us were sent out of the country to do some feasibility studies on how NMetS started. This came out with a lot of MOUs, collaboration with other bodies from different parts of the country. For NMetS, to go deeper into it, after the first trip, a team of experts, AI NMetS expert team was formed. And this team has been sent for training in 3 different countries. And more, they will still go more in the nearest future. So NMetS is working seriously. And based on our strategic plan, NMetS will roll out the first output of the AI team before the end of this year. And we also hope and sure, because the team, like what the presenter was saying, is not what only one person from one angle could handle. So people from different areas are there. And it may even form part of our activities next year. So NMetS and NMetS and the Kenya now, yes, is still working together, but Kenya is still trying to hold that, that aspect. But I'm assuring the person who asked this question about that the caliber of scientists that we have in that team and what they have done so far, there is clear evidence that by the end of this year, NMetS will roll out the first products on the AI and also come up with training activities for people in Nigeria and in other places. So I think that is the technical answer I can give to anybody for now. That the conclusion of the thing is that, yes, NMetS has never folded its hand. The team is working, very young men and women who are coming up with things. Our own, we are there giving them the necessary support. Once it comes up, the collaboration will extend to institutions in Nigeria. And it is costly. That is one thing. And the presenter talked about economic compromise when he was concluding the other time, which is actually true at the beginning. But at the end, obviously, it is far, far better than what we're operating currently. Thank you.
Let's give a round of applause to better of training and research NMetS. That's great. We want Nigeria to be in the forefront. This is showing us. In fact, I'm tempted. Say, we suggest that in advancing meteorology in West Africa, and Nigeria has always been leading, that we maybe have part 2 of this team next year in harnessing AI, machine learning, big data, satellite, and so on. But of course, not going to decide. But that's great. We now ask Professor Dawda Kone. Can I ask you? So I want to ask, please, you would need to come to a place that will be visible. Just say, because they are cross, she will put something on you. She will put the camera on you. And you want?
Yes, I wanted to ask NMetS 2 questions. Number one is, I talked about human capacity. It talks about the issue of human capacity development. Sending to different countries to go and train and things like that. How about the infrastructure? And they will come back to work. Are you also working on it? That's number one question. Number 2, the people would see you and us in Akure as RTC. You industrial component with the plastic components. Yeah, the training center, regional training center. Now, how are you also trying to ensure that these two ends are carried along in this AI and machine learning capacity development for the United? Because NMetS is you and I, you and us. So these are the two things I wanted to.
I should ask Professor Peter to take on. You see, in this world, we need collaborators. And this is a collaborator. We're collaborating with them for a long time. We need to jump process. We don't start making the wheel all over. So in that, I just want to ask, how do we collaborate with those who have gone far so that we can leapfrog? I just want to add that to the question because we know you are great. You are a great collaborator yourself. How do we make time to collaborate along?
Yes, I met when I was making the bridge. NMetS is not going to isolate anybody and said that once we have a test run of what we are doing, then we will spread it out, collaborate with other institutions. True, you know, when you are doing a test run of something, obviously you may not be able to expand it to everywhere now, but you want to know if this thing work, what can we do? This is the extent with which we are doing currently. There is no way there will be separation between NMetS and FUTA and even other metrological institutions in Nigeria. But, you know, in the beginning of everything, you may not be able to understand because what NMetS is even doing is to make sure that they use the numerical weather prediction people who are used to this aspect first and train on the AI aspect and see how it will go. Maturing FUTA and other institutions that is not going to be limited to RTC or limited to NMetS. Like my colleague who asked about the capacity and competence something. He's a NMetS staff and asked the question, thinking maybe something may come from there. If you look at the people that NMetS is making operation with, the training and everything, it is not a one-match show, and it's not going to be a one-match show. So we are with FUTA, and with time, it is going to be NMetS FUTA based. I'm assuring you that. If you, okay, you are not with the DG when he was speaking with some young people yesterday in outside there, and he made it clear to what is intended doing, not only with NMetS, but in other places. So NMetS cannot take the first step in Africa and leave most people who are even training the NMetS staff too, because most of the NMetS staff pass through FUTA, so they cannot get about it. So long as we are there, definitely it will come down. That is, I don't know whether I answered the question. Okay, in terms of infrastructure, NMetS is trying to copy China model. Copying China model. China will send you to somewhere. As you are learning the process there, you are also understanding the machines that you will use in operating them. So before you come, either most of those things are already waiting for you, or as you come, they are there. So if the society can even try to pay some visit to NMetS in terms of tour of the activities, you will see the improvement that NMetS has done in some of this infrastructural development. So we are not training and come back and use, oh, no, it's not like that. So infrastructure is being developed in line with what we want to get. Okay? Thank you. And that is the reason, again, why NMetS is looking for private and public collaboration in terms of infrastructural development. That has been their own activities since last year till now. So as a double chief, if you can even donate or organize a donation for us to get most of the things faster. Thank you.
Very much. Let's give a round of applause. And activities of, because it's in transit, came all the way from Germany and then heading to the UK. I can't see him online now because, oh my God, that's very painful because we want him to actually appreciate. Anyway, Professor Kole will still appreciate him because he loves us. That's why we changed our weather, our climate, our variability is changed with us. We want to appreciate that. We want to be on record because this meeting is being recorded. So we ask him, we'll send him the clip of whatever you said. So Professor Kole, please.
So we have not been able to predict the backhand prediction. So thank you very much. I want to just appreciate also the organizer of this event, who has been very useful for all the participants, from NMetS, from also the society, and also from the professionals who are here, even other people who are not really focused on this methodology, but they are doing also other activities. So we want to say big thank you for really having this event. I want also, on behalf of all of you, WASCAL, also NMetS, the society, to say big thank you to Prof. Sting for his commitment, continued commitment, and also for his availability, his openness also, because it's not easy. Having this huge program and try to connect, we really appreciate this time. And we are grateful. We want to also say that transdisciplinary is very important today. Working together is something even advocated by WMO and also all the institutions want to also engage all of us to not working as a silo, but to try to work collaboration. One person cannot do everything, one institution cannot do everything. Collaboration is key, and we believe on partnership. Partnership also can help us to take over and also to continue to work and deliver accurate information to a large audience for our communities. This is what we really want, because we're sitting here as scientists. People also are waiting for us to get some data. Yes, to try to survive. We need to think about that also. And we need to accelerate every process, whatever we are going to use. And I think this machine learning also can help. Not only, but it can help a lot. And we are grateful. Thank you very much, Prof.
So Andy, Professor Fink has offered apology because he's doing so many things. He had to go. So apology. We'll send him this clip. It's a wonderful session. You can see the issues that we have in our country, the way we labor. These are things, don't labor on internet, labor to get things done. So took us some time, but I'm so happy that this process has been successful. Let's thank God for that and thank God for all the organizers. It's a great thing. Let me call, it's now the next thing to roll out plans for the day. I'm going to shift this. All our keynote addresses are settled. We want the LOC to tell us the other things that are coming out. You're welcome, Professor Demola.
Please, can we have a now? And I know with me, and we are together. And this conference has been very, very successful. And we are moving to the next stage now. The first thing is to appreciate a once sir.
Yes, sir. Yes, that's okay. That's okay. Okay. Yeah.
So we want to thank Dr. Andrea for that insight presentation. Any presentation that attracts several questions, that means it's really, really important. We appreciate you and we hope to call you soon again to give us such a beautiful presentation, possibly like that. Thank you very much. So the next thing now is we go for tea break because this conference is international. So tea break, some of us who have attended the international conference, tea break, after that, tea break, lunch. So we'll go for tea break now. And we are going to have 2 parallel sessions. Instead of moving some of our material, some people will be here and the other will go to 4. I think, yes, the 4th floor. Yeah. And it is that 4th floor we are having the tea break now. So I think the tea break should be for 15, 20 minutes. While for those who want to present online, it will be better they use this place. And the chairman of the parallel section that we hear is the Professor Isi Okokwe. And the rapporteur is Dr. Abuda. So, and the one we are having at the 4th floor, the chairman is Professor Gideon Febune, and the rapporteur will be M.A. Labiru of the University of Jos. So, and I want to announce again that rapporteur and chairman, at the end of the day, we are going to announce chairman of the communique committee and the people that will summarize, starting from the beginning to the end, before we release it to the press. So we are going to announce that during the parallel sessions. Thank you very much.
Let's also say what Professor Kone suggested yesterday. Please, at each of the sessions, the chairman and the rapporteurs and the presenters will stand in the pictures, whether here or up or later in the day. We always, at the end of the session, please stand to take pictures. It's an evidence that you are here, that you took pictures, the chairman, the rapporteur.
Thank you very much. And those chairmen and the rapporteur, they are not permanent chairmen. After the first session, the other session again will have another chairman and rapporteur. Thank you very much. Please, can we just go to the left while we go to the bottom? Thank you.
We have to go. Tell us to know it from your forward precision. Working for our. When is it? Fine. Home. It's almost here.
I see. I will get it. Sorry. So you said that rather than people submit using USB stick, rather than using USB stick to submit their slides, they can scan this code. Okay. And send. And send. Yes. Okay. When they come out, right? Yeah. That's, I know ICT, our ICT is the best. But they borrowed in. Gold can collect extra salary. Okay, you are already salary for. It's extra now. Extra, yeah. No, that's just. Hey. Then they will scan this and then send to the link instead of using their. They should download the link. But you can't go down. There will still be agent. Then it means to be agent in the morning. Now, how did you come? Public taxi. Okay. But by that time, will you be able to guess? Where do you get the lorry there? If you know the one that's a signature, it's always easier to know where you go.
We give it to the technical person or you keep the questions. Listen.
So what?
Not too much. No, that one will be enough for them.
That's enough. They say they're enough.
No, but which one?
See, cyclical scan pieces. Oh, that's for our own. It will not see our own. We have gone extra technical.
Okay, this is something.
So people who come and scan this code, send me that paper there. She will get it.
This is international.
Ah.
Me, I am a manual person. I'm sent course.
Are you presenting here? Are you presenting here?
Anyway, but I was supposed to present. I think yeah, the papers for this place.
See what it was. I didn't listen to you when you were saying those who are prepared.
That's the first. No, Yeah, say no, no, no. The issue is that it's people online that will mostly you give them chance to present. Okay. Yeah, yes. Those then when they are finished, anybody that is if not, send all the people who are presenting manual.
That he has told them. That's all. If I make another announcement, it will come.
No, what I'm saying is that it's only here they can present.
Yes, I
They
know.
can present
But
over there.
he has told them. I mean, Professor Akibobola
That they will be here.
announced those who will be here and those who will go up.
And no, the issue is that even those here and those up, it depends on whether you are here physically or not here. You could be going up or you could be supposed to go up. But if you are presenting online, you have to
this
stay
online.
This no, it doesn't. This group something. All the people presenting online will come here, whether they are in group A or B. Then when they are finished,
They register online.
They register online.
No, the men said they were going to present online.
Yeah. No, they didn't send.
How do we know them?
That's anyone that comes online who is going to present. Virtual. Yeah, virtual. Somehow virtual.
Oh, they are this thing.
But well, the issue is that anybody who is going to have a virtual presentation, it should be here.
So can we do this way that we have physical presentations first?
No. The virtual presentations.
You know the essence of sharing the value.
We are following a particular schedule.
No, it doesn't matter. There are presenting virtual. Let them present first.
Okay. Prof, I hope I have not displaced you.
I will share our screen.
Stand down. If you are anything, stand. Then share your slide.
You are doing virtual. Now when they finish,
Yes.
and then you can be going to first virtual.
Any slide.
2 minutes.
Oh, but your phone must have a.
Sorry.
You are presenting here. One standard good. I told you. How do I catch it? How do I catch those percent of what you know? I will show some example of things. What's it? Okay. Yeah, this is number 2. What you got the match? The middle pass item. Yeah, it's actually what I need is just basics. Just have to understand able to
What's going on? Let me say that. Sure, if there is a client should do something. Okay, let's see. So where is it? I mean, we're doing after this one, which is somebody that I got.
Sir, that thing that pops up, just start to take it to WhatsApp for sure.
That is Zoom link. Somebody, we have to prevent people from going through that side. It's one of my leg things. Actually, we have to stop people from going through that side. Yes, absolutely. Yes, absolutely. Yes. There's paper here. They have paper here. Yeah, yes, I will come back. So that's number. Which number? One is able to scan and also show the person's WhatsApp. Okay, it's WhatsApp number. Emmanuel. Some number so that it's able to add the number. Just because I can't even find. I have added it. I can't find it. So you add them. No, I said this. Wait a minute. It's like send to WhatsApp. Yeah, you want to see. You send it to me. It's like what is the number is says. You know who I said. So basically.
Sorry, I want to look at
Share. Are you present?
yes.
Your listen, sharing this. Fire. Sorry. Victor, do you have a number of these driver that is driving Corona? You are presenting, kindly share your slides. I have something inside. Can code with the share your rider. It's a dispatch logo. Scan this code. Okay. Scan this and share your slides. So where is? I think we need to know the order of presentation. Yeah, but how do we know those? I said, how do we know those who are online? Okay, all those people are online. Oh, okay. Okay, maybe we'll announce to them that people are announce to those online. I think you are presenting, please indicate so that we think in chat. I don't think they can hear. Oh, we need to mic to work. We need to mic to work. Okay. Please, those online, if you know that you are presenting, kindly indicate in the chat picture. Right? Kindly indicate in the at the message, the chat box that you are presenting. That draw up and order. Thank you. Okay. Abigail is going to say.
Also, I so that.
So, let's help us be checking the charts. If people are indicating they are presenting online. You can confirm. It's that. Okay. What number 2 is here? Number 1. Who's number 1 again? Yeah. Number 2 is here. What is your number? So then you have this. It's not good.
Yes, you said I We didn't start with Okoye, that's why. I think that's not. That'll be number what?
No, we want to confirm those who are present there, those who are agreeing. So, please, I want to believe that. HI OGA, it's all are you here? Artificial intelligence in weather forecasting, advancing predictive accuracy, and decision support systems. Usman, sorry, the person driving the Corolla, do you have his number? Eh? Oh, okay. I just wanted to have his number. Okay, send me his number so that when I have something inside his car that somebody, a dispatch rider, will come and take. So when the person calls me, then I'll call him and come down. Then just are you here? Oluwatimileyin Adeyinka. Oluwatimileyin Adeyinka. Labiru at all, right? Labiru is so this is for what I'm saying. Labiru is doing laboratory. Who are those? Which category are those that are officers? Yeah, everybody. This is room B. This is Robinson. I'm supposed to be. How do you do that? This is room A. Room A. Room B. Room B. Room A. So maybe we'll ask Nabil. Sorry, Nabil to present there. Okay. Then when it's your turn, you present here. Yeah, okay. All right. So then. Let me call the people. Have you identified anybody? Have you identified anybody online? Has anybody sent a message?
No one have sent it.
It's
still online. No one.
Okay. Some perceptions of the impact of rainfall figurines on yam production in Adi district of local government area of Borno State, Nigeria. Are you here? Hillary. Okay. Oluwayomife. Oluwayomife. The effect of climate viability of cocoa production for those states. Adetayo Adewale. Adetayo Adewale.
Maybe when it's your turn to present, you present there. So that because the rapporteur here is also presenting and his name is down. So when you will present there and he will present here. Is that okay? Okay. Okay, I'll read data. Okay. Okay, then all right.
Okay, so I again, Sani Ahmad is virtual.
Yes, sir.
Virtual. Are you there?
Yes, I'm available. I'm here.
All right, thank you. Thank you.
Welcome, sir.
Yes,
Welcome, sir.
So you are going to present first. So Sani Ahmad, you are presenting first. You understand by get ready.
Okay.
Yes,
Hello?
please. Yes, I'm here. Good afternoon.
Thank you very much. Present Sani Ahmed to be the second presenter.
Thank you very much.
H.I. Olga. H.I. Olga. Physically or remotely.
Okay. Ask if there's anybody online. Let them identify themselves.
Please, for our virtual participants, if you know you are presenting, please let me indicate in the chat box, chat picture, so that we can take notes. Thank you. Maxwell Isioro, you are the third presenter. Usman, you are the fourth presenter.
Is Usman here?
Yes, he's here. So, we take this first four.
Yeah, okay. Take that
four, then we now call on the next.
Yes.
Okay. AV Arowolo. AV Arowolo.
Victor should be upstairs. Maybe. No, I thought he was upstairs. Maybe what is his topic?
Assessing the effect of solar radiation modification on precision indices over Nigeria.
Maybe try it.
Okay, are you here? Okay, you're there. So if those two are not here, Oluwabu Kola Babalola will be the fifth presenter. All right. So we'll wait for that. All right. All right. Once again, ladies and gentlemen, you're welcome. Good afternoon. If you know you're going to present, we still have the code on the screen. Kindly scan that code and send your presentation so that we can have a seamless and smooth session. Yeah, who else have that code? If you are presenting.
If you are presenting here, let's have this code. You have sent your paper.
Okay. So I am Dr. Emmanuel Awega. I'm the rapporteur for this session, but I don't have the power and authority to address us before the session starts. So I will hand over to my chairman, Professor, and that is my namesake, Professor Emmanuel Okongwe, to get us started for this session. Thank you and welcome.
Okay, thank you everyone. This session we're going to be smart. We'll start our smartness. We are giving the code that we scan and send your paper there so that we have instead of the moving skills all around. That's number one. Number two, how many minutes do we have for presentation? How many minutes? Yeah, 15 minutes of presentation. There are 4 people that will present. After those 4, we will take questions from the 4. And then take another part. 2 persons are presenting from partially, they know themselves already, and then 2 other persons presenting there. Process of presentation will also ask those yeah, and then so and we are starting now. And please keep to time and
Who is going to be a timekeeper? Okay. For try, you'll be a timekeeper. You give notice when the person has 5 minutes to go, when they have spent 10 minutes. So who is that person that is selling?
Yes, sir.
Selling. Alma, please share your presentation slides. And then we will sorry?
What the first person? Can Ahmad the first person?
Sorry, yes. We told you share your slide. Share your slide immediately, and then put the other person. Like Diagi projects. Yeah? Diagi. And then Diagi projects, you will also be ready after then you will present. And then two other people present. Yes, we can hear you.
Sharing the talk aloud. Sharing the talk aloud. Sharing the talk aloud. Sharing the talk aloud. Sharing the talk aloud.
Okay, let's go. Okay, Akpet, you can share your screen. Share your screen.
Sharing the talk aloud.
Yes, Dr. Osanyama, please share your screen. Are you there? Are you there?
Yes, sir.
Okay. Are you having difficulty sharing your screen? Okay. Let's copy that.
Can you see it?
Right. I can see it. You can now do a slideshow.
Okay.
All right. So your time starts now. You have 15 minutes.
Good afternoon, the chairman. Global climate system is undergoing unprecedented change. Frequency and intensity of extreme weather events rising all over the region. Nigeria with diverse climatic zones ranging from mangrove to savanna to Sahel in the north is particularly vulnerable to climate variability. National meteorological and hydrological services worldwide will act as the first line of defense against weather-related disasters. In Nigeria, the professional forecasters relies on collection of numerical weather prediction models, such as DRP-WACS, IPONS, Cosmo, WACS. These WACS are the products of WACS. These physics-based models call fundamental equations of spherical dynamics have been developed and refined over decades, each offering specific strengths in global coverage. However, those traditional numerical weather prediction models face inherent limitations based on their computationally expensive, requiring supercomputing infrastructure costing tens of millions of dollars with single forecast runs taking hours and thousands of people. The emergence of AI big data analytics offers paradigm shift. These advances have enabled the development of global weather indicators that reduce complex numerical tasks, data-driven operations, accomplished within minutes of a single graphic processing unit, achieving speeds of up to 10,000, 50,000 times faster than the traditional numerical data prediction. Primary models include forecastness, undo weather, graph plots, among others. These AI weather prediction models are typically trained on the ERA 5 analysis data set. Concurrently, the big data revolution has transformed the observational landscape through new satellites, commercial weather radar networks, Internet of Things, enabling dense surface networks, and cloud processing. So this paper aims to address that question. What are the current capabilities and applications of AI and big data? How do these technologies compare with traditional numerical weather models? Then the third one, how can AI and big data approaches complement existing models to focus in particularly in applications? The fourth one, how can AI enhance meteorological services contribute to climate resilience across key economic sectors in Nigeria? The study uses a systematic literature review and synthesis to answer the four questions. Literature from 2022 to 2023 was reviewed to capture recent advances in AI weather prediction. Sources include peer-reviewed articles, conference papers, and others. So the AI capabilities. Hello? Hello?
All my listeners are not hearing you. So the more
I can hear you.
Move closer to your microphone device. Your device.
Okay.
Voice will be low.
Okay, the capabilities of AI computational. Hello, sir.
Yeah, go ahead, man. It's better now.
Okay. The capabilities of AI models, AI predicting weather prediction models, the AI models achieve speed of up to 10,000 to 50,000 times compared to traditional numerical weather running within minutes on a single graphic. The
Dr. Sani, can you turn off your video? That will help with the network connection. You may turn off your video so that we'll have a smoother presentation. Dr. Sani, are you there? Sani, you're out. That's it. Maybe we have to start with. Bridget, can you share your own screen?
Okay, thank you very much.
After sharing, you can remove your video so that your
Please, can you see my slide?
Yes.
Should I put off the video so that for clarity purpose?
That's exactly what I said.
Okay, so let me put
yeah.
Okay, good afternoon. My name is Diagi Bridget. Yet I'm presenting a paper on unmasking the research trajectory of digital twin technology in Nigeria's climate resilience initiative using the bibliometric systematic analysis. This work mapped the authorship as well as the institutional research base and conceptual trend on digital twin technology. So that's the outline for my presentation, a brief background to the study, the aim and objective of this study, the research question, as well as the methodology that we adopted in our research work, the findings, our conclusion, and few references. Digital twin technology is a process that involves the application of AI as well as machine learning method, geospatial tools and data such as satellite imagery, aerial photograph, land resources layers to try to solve spatially explicit problems that we find in the environment. And in the area of climate change, digital twin technology that includes the GeoAI and remote sensing, as well as GIS, enable automated climate change resilience by supporting predictions of precipitation, crop mapping, yield prediction, the spread of disease, as well as the detection of disease, and also in the area of fertilization optimization. The digital twin technology is particularly useful in some areas that are directly linked to multiple SDGs. So we have SDG 2, which talks about zero hunger, SDG 6,
that talks about clean water and sanitation, SDG 13 that talks about climate action, as well as SDG 15 that talks about life on land. But despite the growing use of this technology, we discovered that in Nigeria, not so many research areas have actually keyed into this area of digital twin technology. Hence, the essence of this work to try to map the research trajectory of digital twin technology. So the aim of this study is, like I've said, is to map the research trajectory of digital twin technology in Nigeria, looking at the area of climate resilience initiative using a hybrid approach, which is the bibliometric as well as the systematic approach. The objective was to trace the annual publication trend and key journals that have made publications in this area, try to identify the leading institutions, authors, and the collaborative efforts that have been made in the area of digital twin technology. And finally, in this paper, we also try to examine dominant concepts, keywords, as well as the SDGs that I've mentioned that are relevant to this work. The research questions: what are the annual growth patterns and journal clusters dynamic in Nigeria's digital twin technology? Looking at the climate resilience research, which institutions, authors, and international partners actually dominate this area of digital twin technology? Then what are the keyword clusters that are used in finding articles related to digital twin technology? Our data sources. For this work, our search was in Scopus and Web of Science in their core collection. And the keywords that we used in searching for our materials include the digital twin, digital geospatial technology with climate resilience. We also looked at the area of climate mitigation as well as adaptations and actions in Nigeria. So our initial record was about 1,973 documents, but finally we made use of 452 English language research and review articles. So this article basically were between the area and the time of 1998 to 2026. And what was included in this search were empirical, qualitative as well as quantitative studies that has to do with digital twin technology, geospatial tech, and climate-related studies that were based in Nigeria. Certain areas were excluded from our search. We excluded the great literature, the non-empirical work, studies that were not focused on Nigeria, as well as studies that were not done using the English language. For our methodology, we exported records with authors, titles, affiliation, keywords, citation, the years of publication, as well as references. The tools that we used for this particular work were the VOS viewer, which helped us to look at the co-occurrence, the bibliographic coupling, the network overlay, as well as Excel. We used the notepad for our descriptive statistics and presented our works in form of tables and graphs. In the area of analysis, we looked at the trend. We looked at the annual trend in publication, the clusters of journal, institutions that have done one form of collaboration or the other. And we also looked at certain keywords that we used in searching for material. So our study revealed an annual growth rate of less than 5.8%. This was in 2025 alone, that contributed about 63.67% of all publication. Now, this tells us that there's a rapid increase, awareness in the area of digital twin technology. Now, for journals that had the highest number of paper, we have sustainability, which had about 14 papers, while science of the total environment achieved the highest citation of about 318. In the area of journal network analysis, it revealed 4 clusters around environmental science, in the area of soil science, the area of food system, as well as sustainability. Journal publication and network analysis. Sustainability in this area recorded about 14 papers. Science of the total environment had about 318 citations. And of course, the area of cluster. Institutions as well as their collaboration. The top institutions were that of University of Ibadan, having about 10.18%, University of Nigeria, Usuka, having a percentage of 7.74%, as well as the University of Federal University of Technology, Akure, having about 7.5% institution-based collaboration. Strong national authorship link among Nigerian universities was with UI, UNN, as well as FUTA, which in this study, we regard them as the major hub when it has to do with digital twin technology. Now, in the area of collaboration with international scholars, Nigerian authors collaborated mostly with scholars from the United Kingdom, the United States, South Africa, China, Germany, as well as Ghana. Key authors and thematic area. Leading authors in the area of digital twin technology include Adelekon Ibidu and Water Fuel, which reflects a strong climate change expertise and global network. The keyword cluster include the climate change, food security, adaptation, poverty, as well as sustainable development in Nigeria. Key variables include temperature, rainfall, drought, impacts, and all that. So this is the search that involve the SDG as well as the research area distribution. The most targeted SDG, like I mentioned in the introduction, is the climate action, the zero hunger, the life below water. The climate action in this study had about 21%. The zero hunger had about 17%, and life below water had about 16%. Dominant research area include the area of agriculture, which showed about 27%. Environmental sciences / ecology recorded about 20%. Food science and technology recorded about 12%, plus the area of remote sensing, computer science, and economics. Digital twin technology, therefore, is positioned as a nexus of science resilience, food system, and sustainable development in Nigeria. So key insights include the Nigeria digital twin technology, which has to do with the climate research. And we can see that this is actually rising because we are having about 10% of global output in this area of research. What is the Nigerian role in the global landscape? Nigeria publication trend, like I said in the slide before this, is actually rising, but we still need a lot of contribution because we can see from the result that we have less than 10% that we are contributing globally in the area of digital twin technology. And so the areas that need to be strengthened in the area of collaboration as well as research has to do with the area of South-South and the North-South. Because from our study, we discovered that the South-South and the North-South really haven't done much in this area. And so the novelty of this work is that it's actually the first that has a combination of VOS viewer and trying to look at research-based analysis in the area of digital twin technology. Conclusion and policy implication, bibliometric as well as systematic mapping helps us to clarify who is doing what, where is it done, and with whom is this done in digital twin technology. So evidence shows that digital twin technology and Joe AI are already supporting climate resilience, which is very key, as well as in the area of agriculture and multiple SDG. So our findings in this area, can guide funding agency, can also guide us in the area of policy, as well as universities that could leverage on the digital twin technology in order to support food security and also to try to close the gap in the SDGs in the region and within Nigeria. Thank you for your time. Those are some of the references that were used in the study. Thank you very much.
Let's, I will want to stay by after the next two persons. Then we will take questions where you will make responses. So,
thank you very much.
Sani, are you back? It's not online, is it? Dr. Sani Ahmed, are you back online? Okay, was. Okay. Where is this? Right.
Yes, so the next, thank you very much once again, Dr. Giagi Bridget, for your presentation. We shall be having the next presentation by Dr. Maxwell Kisiro, who is going to present on the optimization of temperature forecasting in Lagos using high precision machine learning approach and ERA 5 reanalysis data, 2010.
Okay.
2025.
Dr. Maxwell, your time, okay, starts. They have not shared your slide. Have you submitted it?
Have you confirmed the register?
Maxwell, you paid, you registered, and you paid. Okay. Dr. Bridget, did you register for this conference?
Yes.
Yes, I did.
She did. Okay, Dr. Ahmed, are you back online? Okay, please, if you are presenting, make sure you are registered before you come up to present. Yeah. Yes. Okay, Doctor. Yes. Time starts now. 15 minutes.
Good afternoon, ladies and gentlemen. My name is Maxwell Siro, not a doctor yet. I work with the Nigerian Meteorological Agency as an instructor with ROTC. I'm here to present a paper titled Optimization of Temperature Forecasting in Lagos using High Precision Machine Learning Approach and ERA 5 reanalysis data for 16 years under the sub-team Artificial Intelligence for Forecasting. One of the challenges we have with weather forecasting is the chaotic nature of weather. Unlike normal physics principle, when you say V equals to U plus 8, it's a straight line. You can easily deduce where you are going to from point A to point B. But when it comes to weather, it's quite a different ballgame entirely, because along that straight line, there are variables that will throw your model out of place. That is why it's very difficult predicting weather. The standard models for weather prediction as we speak today are the NWP models, which is the numerical weather prediction models.
No, I think it's not us.
The accuracy of temperature forecast impacts public health. This study evaluates whether domain-specific thermodynamic predictors improve weather forecast. What do I mean by that? NWP models are usually very generalized. Now, I want to forecast weather for University of Lagos, for example. University of Lagos have peculiarities different from the entire Yaba. So I might take the cognizance, I might take the trees here, I might take the moisture content, I might take different things. Urban heat island within the lake, within University of Lagos might be different from those in the other team. So those are domain-specific predictors that I was referring to. Now, before now, I'm a Google developer, so I write codes and I develop solutions for. Now, for example, somebody asked me, write a program that will help me count how many stores I have in Lagos. You can easily whip up some script and will write a program. Somebody will ask me, write a program that will predict temperature in the University of Lagos. I cannot do that. Why can't I do that? Because there are several variables that I cannot. In fact, I have attended it before, and the program performed woefully. Because what? There are several variables that you cannot actually contain that will throw your forecast out of place. That is where the numerical weather prediction, which are physics-based models, struggle. So they struggle a lot with that. So where does machine learning come? Machine learning is simply a process whereby machine learns from past events. If you have noticed, for example, you wake up 5 o'clock every morning because you set your alarm by 5 a.m. So every morning by 5 a.m. you wake up, let's say for a period of 6 years, you will realize that if you don't set your alarm any longer, you will start to wake up by that 5 o'clock. It's not so. Now that is your body has learned how to wake up by itself. So machine can also learn from past data and begin to behave as though they are real. That's where we have artificial intelligence and machine learning. This is actually an equation of state of the atmosphere. You can see there are several variables that actually come together to form the NWP models. Mathematically, this is very difficult. That's why I respect those in the atmospheric sciences domain. So the atmosphere is not a linear structure, it's a non-linear structure. If I say y equals to mx plus c, I believe y and x are linearly related. So I can plot a graph of y and x and I can get a straight line. I can plot a graph of y equals to ax plus bx squared plus c. I will get a quadratic equation. Is that not so? Because I can predict. In this particular case for weather, you can't do that. You can't predict straight line for weather. It's always chaotic. Now, this study focuses on Lagos. Lagos particularly because I wanted to find out how moisture affects temperature forecast. Air temperature and dew points were obtained from era 5, 5th generation atmospheric reanalysis for 16 years between 2010 and 2015 at 2 meters and used for this study. This is actually a description of data, 5,888 data set used for this. And the machine learning algorithm that was used is called the extreme gradient boost algorithm, XGBoost. There are several algorithms. We have the random forest. We have the neural networks that we use for image recognition. We have the LLM that we use for our GPT. But in this particular case, the XGBoost is particularly suited for tabular data, which are structured tabular data. And more so, they can also, for example, in Africa, we have very sparse network of meteorological stations. So the XGBoost can actually forecast using yesterday's temperature, or rather, let us assume we have point A and point B, or rather point A and point C. We are supposed to have a station at point B, but there's no station there. XGBoost can actually forecast what the temperature will be in that point B by learning from past data. And this is how the whole algorithm evolved over time. It didn't just start all over. You just start in the vacuum. Decision tree about random forest boosting, then we have the XGBoost by that. Now, this particular project, this particular study, how was it framed? It was framed such that, okay, fine, I have past data. Forecast. I want to write a model that will forecast for tomorrow using past data. My predictor is simply temporal. Can the model learn from past climatological data to predict tomorrow's data, to predict tomorrow's information? That's the first, let me say, feature. The second one was, okay, what if I allow the model see yesterday's data? Will the prediction be better? That is the second feature. The third feature is, okay, what if I allow the model also see the dew point in addition to the temperature? Will the model be better? That is exactly what it's about. So the feature engineering framework, which is capable of transforming variables. So 3 feature sets corresponding to our ablation study. We have model to isolate the marginal contribution of each predictor variable, as I've just explained. So now the model A, which I said temporal only, temperature is influenced by embedded diurnal seasonal climatological information. That's for model A. So let us understand, if I give this model, which is this XGBoost, let me forecast. How will it forecast using only climatological data for temperature alone? Then, okay, XGBoost, I have added yesterday's information. Can you forecast climatological? Can you forecast tomorrow's temperature using past information and the recent information? How will you perform? Okay, XGBoost, if I also add dew point, how well will you perform? That's these 3 you are seeing here. So that's temporal, autoregressive, and thermodynamic. Autoregressive here is looking at yesterday. Now, how did I evaluate the performance of this model? How good is the model? The model now tells you if you have no error. If the model can actually predict accurately, it means that let us assume that it predicted accurately. It means that your RMSC, which is your root mean square error, will be 0. So now it is through this error you will know how well the model performed. The higher the error, the less predictive your model is. Now, after performing the whole analysis on this model, what did I do? Out of the 16 years data, from this point A to this point B, now I used 13 years to train the model. 13 years. And I use, okay, now you have learned how this data set is for 15 years. Can you predict the next 3 years? You know, I said I used 16 years. So now you have learned the pattern in these 13 years. Can you predict the next 3 years? So we used 80% for training, 20% for testing. So having done first one, 0.77 was the root mean square error using only climatological data. What that means, if the actual temperature is supposed to be 30 degrees, this model predicted 29.3 degrees. If the 29.3 degrees are plus or minus, or 30.77 degrees. Using model B, as in adding autoregression, the model predicted, or rather the RMSC error reduced, meaning that the model performed better, 0.71. Then having added thermodynamic, which is your dew point, in this particular case, moisture, the RMSC reduced further to 0.65.
5 more minutes.
So this is a graph showing, this is the bar chart showing you how the error reduced across the model. Now you can see this particular graph, the blue line in the first image shows you the actual temperature that the model that was actually the case. The orange line shows you what the model predicted. You can see it's following it fairly well. While the other side, that one shows you the predicted value versus the actual values. So the green lines are scattered around the red line. The red line is the reference point, which is the perfect prediction. You can see the green line that's scattered around, so it's not very perfect for only temporal. For temporal plus auto regression, you can see that the orange line mimicked the blue line fairly better than the first one. And the other shows you that the green dots are closer to the red line. Likewise, for the third one, when we added moisture, the orange line performed better, following how the actual temperature actually is. And you can see that the green line are better clustered around something. So now, discussion. Somebody else has done this work before, and what the person simply did, which is PBS 2024, what the person did was to simply test all the models available. She wanted to know which of these models perform better in what. Temperature is better evaluated by what model, dew point by what model, solar radiation by what model. That was what the person actually did. And the person's result was that 1.374 using XGBoost algorithm for temperature forecasting. But this favorably compares to the study's ROMSC of 0.65 obtained in the course of the study when specific thermodynamic variable is incorporated in the modeling process. So now, NWP models are very expensive to deploy because of the computational requirements. You can start modeling a particular variable for the next 24 hours and uses a lot of power. This particular one requires such power. Why? Because the algorithm is learning, just learning. It's not actually computing. So the low implementation requirements, as demonstrated in this study, makes ML algorithms a growing alternative. They're not replacing WP yet. Over other physics-based models in resource specifications. This work also corroborates the growing recognition of lightweight ML algorithms in forecasting weather variables with near accuracy at a quicker time.
Almost 12, almost 30 minutes. Almost 30 minutes. So did a good job time-wise. So you after the next presentation, then we'll take the questions together. Go ahead. Time. Go ahead, yeah. What do you know about that? Dr. Sani Ahmad. Watch on the ground, don't match it.
I have not found this on. Dr. Miller, are you here? Okay, so please get set.
Go after him, so because Ahmed did not come back.
Your work is submitted, right?
So after
Dr. Hillary, Dr. Umamaka, get ready. Let me submit you. Yeah, sure. After.
Okay, your time starts counting down. No, this is your destiny. Yeah. Yeah. So set the time. 15 minutes, clock counting now.
The chairman, my fellow colleagues, permit me to stand on the already established protocol. My name is Okoye Kwekiruka. I'm here to present a work, quantitative analysis of frame temperature impacts on sustainable ginger production in contrasting climate belts in Nigeria. We know that temperature and rainfall are climatic variables that determine the start and end of a relevant agricultural growing season in Nigeria. And as climate of Nigeria varies over space and time across the 4 contrasting climate belts, sustainable ginger production will likely respond to the variations in climates. The problem statements. There is depth of information on comprehensive review geared towards ascertaining the impacts of climate variability on sustainable ginger production and the climate based on Nigeria. The most of the work that was seen online were done only on a particular, either on a particular state or a particular climatic belt or in a local government. So the need for the work to check the climatic variable impact of ginger production across the 4 climate belts of Nigeria. The objective of the work is to examine the characteristics of rainfall and temperature trends over the contrasting climate belts of Nigeria from 1980 to 2019. And secondly, to assess the relationship between ginger yield to trends in climate variables in the contrasting climate belts of Nigeria between 1980 to 2019. Methodology. The study area is Nigeria. According to Coping's classification, the space with blue is the tropical monsoon, followed by tropical savanna, then warm semi-arid, then the peak is the warm desert climate. The climate variables that we use as secondary data, both climate and the rain and the ginger yield, they are secondary data. The climate variables were collected from the Nigerian Meteorological Agency, Abuja, while the crop yield data they are gotten from Nigerian Bureau of Statistics, Abuja. Results and discussion. From the table, we find that the table shows monthly rainfall distribution across the climate belts in Nigeria. Tropical monsoon, tropical savanna, warm semi-arid, and warm desert climates. From the table, we will find out that in tropical monsoon, there is rainfall all through the year. But the highest rainfall occurred in September, followed by July. While in tropical savanna, the highest rainfall occurred as well in September and followed by July. But in warm semi-arid climate and warm desert climate, the highest amount of rainfall there were recorded in August, while the lowest amount of rainfall for tropical monsoon climates were recorded in December, while the tropical savanna was recorded in January, while the warm semi-arid, its lowest amount of rainfall were recorded both in November and December. For warm desert climates, January, February, November, and December recorded the lowest amount of rainfall. Figure 2 shows the mean monthly temperature distribution across the climate belts of Nigeria. From the graph, we can find out that the warm desert climate is having the highest amount of temperature from the graph, which means that it has from April to June shows the most that warm desert climate exhibits highest amount of rainfall, while the other climate belts slightly there is not much difference between the other climates between that April, May, and June. Even though the graphs are above 20.0 degrees Celsius.
And remember the third figure shows rainfall and temperature time series and anomaly plots for the tropical monsoon climate belt. The first graph is rainfall for the tropical monsoon, while the second scatter graph beside it shows the scatter graph just for us to see the years that really exhibited the lowest amount of it, so that we'll be able to know the actual trend of the variable. Like here in tropical monsoon, rainfall is relatively stable with modest year-to-year variation. There is no strong increasing or decreasing trend. While from the anomaly graph, we can see positive and negative spikes. There is an irregular pattern. There is no regular pattern that you can say it is either increasing or decreasing. While in the temperature, the second graph is temperature graph. It is showing that it is sliding up. There is an upward trend, even though it is warming gradually. It's not a very high spark. While in the scatter graph, there is a substantial positive anomaly peak, which means there is a lot of positive and negative years that will have either highest amount of rainfall or lowest amount of rainfall. That is the same thing was carried out in tropical savanna climate. From this, we can as well find out that the first one is the rainfall graph for tropical savanna belts. Here we find out that there is modest interannual variability with values generally between 1,200 and 1,800 millimeters, which is gradually upward trend, which is gradually showing a gradual upward trend in rainfall. Then the anomaly graph shows the fluctuations around it. There are a lot of positive and negative fluctuations. Then the third graph shows the temperature table, temperature graph for this climate belt, tropical savanna. From the temperature, we can notice the interannual fluctuations, and there is still slow and steady rise. And still there is more frequent positive and negative anomalies from the anomaly graph. Then the third graph shows the warm semi-arid. From the warm semi-arid, we can notice that there is an increasing rainfall with fluctuations, but the overall trend is upward. There are more drier years than wetter years. Then from the anomaly graph, we found out that there are more years that are very close to zero than the years that had enough rainfall, more rainfall. The third graph shows the temperature of the warm semi-arid. From the warm semi-arid temperature graph, we found out that there is clear increasing trend, rise from about 24 degrees Celsius in 1980 to about 27 degrees Celsius in recent years. Then the anomaly graph shows more recent years show positive anomaly. The last one is the warm desert climate. From the graph, we found out that there is an overall, the rainfall stays fairly steady with a slight increase over time. The anomaly shows a lot of variations, years much wetter or drier than normal. Then from the temperature, we find out that there is gentle upward trend with a very slight rise in recent years. The moving average is very, very stable. Then from the anomaly graph, we find out that it fluctuates, then became stable between 2001 to 2011. Remember the second objective. So the second objective was to find out the relationship between climate variables and ginger yield. So this is the table that shows the relationship between rainfall and ginger yield. From the table, we found out that there is all the p-value are significant, but at different significance level. If you check tropical monsoon, tropical savanna, warm semi-arid, and warm desert climate, they are all significant, meaning that rainfall and temperature predicted the yield of ginger in all the states, in all the climate belts, but the prediction is at different level, significant level. This means the conclusion and recommendation. Over the 40 years studied across the climatic belt, we can find out that a new season is emerging. From the tropical monsoon, we found out that before, rainfall was not all through the year. This, we normally say that rainfall starts around March or April. But from the table, we found out that rainfall is all through the year from January to December. Then it means that a new season is emerging as rainfall. Then increased climate variability makes it harder for farmers to predict the best planting time and managing their crops effectively. Recommendations. Amid the escalating global climate change and variability, the study urges aligning ginger farming with evolving seasonal patterns specific to each climate belt. Now that we have seen that rainfall is all through in tropical monsoonal climate belts, one can plan how to plant it, then know when there is dry season as to plan when to go either for weeding and then plan for harvesting and how to store it. Then the study advocates for policies promoting climate smart practices, development of climate resilient ginger varieties to ensure sustainable production. Thank you.
Thank you, Dr. Koye. So you said about assessment too. What's it? Usman. Okay. Usman is the next person. Usman, and that's the last for this session. Then after that, we'll take questions. Then we'll now start another series. Dr. Sani Ahmed, are you there? If you are there, please. Dr. Sani, are you online now? Okay, after this presentation, we will use the style we use at Okitumpa. After this, those who are here will step out. Then we will now take questions for the those who are presented will step out, and then the online person will be there, and then we will now ask questions, take questions, and then you respond to the questions.
Good afternoon, everyone. I would like to thank the organizers of this event, and I welcome everyone to my presentation. My name is Ajalaru Usman Olamilekon. I work as a climate scientist at Climate in Africa, maybe Africa here in Lagos. So my presentation today is titled Enhancing Air Quality Forecast Reliability in Machine Learning Calibration for PAMS PM2.5 PM10 using ground-based measurement in Lagos. The goal of this study is to look how calibration, noise sensors, and machine learning can transform global models and enhance their ability in near-real estimate. Okay. In Africa, rapid urbanization is outpacing infrastructural development. And in Lagos, which is home to about over 20 million people, that studies have shown that Lagos is exposed to air quality exceed WHO guidelines by about 5%. And this is caused by anthropogenic activities such as biomass burning, generator usage, and a lot of other activities. And PM 2.5 have been shown that it infiltrates deep into our lungs, driving asthma and reducing lung function. And the PM 2.5, sorry for that. And the PM10 also causes reduced lung function, particularly in the elderly and in children. And Lagos has been shown that it has limited monitoring networks for this. Hence, there's a need for grounded air quality monitoring to inform public health action, guide policy, and protect vulnerable populations. The next thing is on slide is the GAMS Copernicus atmospheric monitoring service. So in regions whereby there is limited ground-based monitoring network to inform this in global models such as this, they give out spatial data in regions whereby there are no so much network of monitoring stations. And the Copernicus atmospheric monitoring service CAMS delivers global near real-time forecast of atmospheric composition twice daily. The data set contains include PM 2.5, PM10, and other 50 chemical species such as the ozone, the nitrous oxide, carbon monoxide, black carbon, sea salt, and other atmospheric composition. And it is partially gives spatial data over the global, over Asia, over Africa, and other continents. And also gives data twice in a day, which is the 000 and the 1200 UTC, and it is freely available by the atmospheric data source. However, the reality is that this data set operates at a resolution of about 40 kilometers, which is about 0.4 degrees by 0.4 degrees. So the real question we need to ask is, does this data set can it capture what we are really emitting on the ground? And the second question is, how can we use machine learning to bridge the gap between this coarse resolution of global data set and the new near ground estimate? Machine learning over the years has been used by various studies in terms of climate analysis, numerical weather predictions, and other usage in climate data analytics. But some other studies have also used these machine learning models, such as the random forest, the XGBoost, the CatBoost, linear regression, ANN, KNN, and a lot of other models predict and forecast the dispersion of this particulate matter. So the question that needs to be asked is that do CAMS can it actually reflect what we are really emitting? Second question is, can we use machine learning to bridge the gap between what is showing on the satellite data, because of course the CAMS data is the satellite data, and what we are really emitting. So the study objectives of this is, number one, is to quantify CAMS forecast performance against the in-situ PM 2.5 using deployed sensor network. Second one is to develop and test a machine learning calibration framework using CAMS forecast data, error 5 methodological variables, and ground observation from myriad devices. And the third objective of this study is to identify the most accurate model across different environments. But we need to ask, why do we need to calibrate CAMS data? Studies have shown that this CAMS data operates as a very vast solution of about 40 kilometers, and it might not be able to resolve the diurnal spikes, and or sometimes will under-predict and over-predict some episodic events. And also, calibration will enable a near real-time, realistic site-specific PM estimate and turn global forecast into locally actionable air quality information. So the study we are used in this study is Lagos, which is home to over 20 million people, according to recent study. And we used 4 locations for this study, which is the Baja, which is a very high dense place in Lagos. Next location is the Mabaya, which is in Lekki. The third one is in Ikobo and Ikodu. That one is the Ikodu. Ikobo and Ikodu are in the northern region of Lagos, and they are in a place whereby there is high industrial activities. And for the arms data, we paired it with in-situ data from the main year, and the data from it is PM2.5 and PM10. And also, we paired these 2 data sets with 5 variables, which include the temperature, dew point, relative humidity, wind speed, boundary layer height, and surface pressures. These variables, temperature and the other meteorological variables, has been studied, and meteorologically, they have influence on the dispersion of this particulate matter. Particularly, the temperature, when there is high temperature, it leads to a differential heating, which causes like an increased wind speed, which disperses PM2.5 and 10. Relative humidity also have an influence on PM2.5 and 10 as they lead to the hygroscopic growth of this particulate matter. Boundary wind speed disperses these PMs, and boundary layer height traps PM based on its height. So moving on, the study period of this is we used hourly measurement from October 1st, 2025 to December 31st, 2025. So this is the device we use for calculating the camp data. It is called the Mary Air device. It records 14 variables including temperature, humidity, pressure, and atmospheric components such as the particulate matter, PM2.5, PM10, ozone, and other gaseous pollutants. So the methodology overview of what we did is we used 4 machine learning models, including linear regression, multiple linear regression, random forest regressor, and support vector regressor. And we used the fundamental rule of building statistical models, which we train the data set on 80% of the data and 20% on testing. And after testing, we use the overall data set, the models on the overall data set to see how well they fit on the overall data set. So for the metrics we use in quantifying the best model, we use 5 performance metrics. First one being the Pearson correlation, which has a range between -1 and +1, in which -1 shows strongly negatively correlated, +1 shows very positively correlated. We also have the MAE, which is the mean absolute error, and the MAPE, which is the mean absolute percentage error, which this value indicates a very high accurate model. We also use the ratio of error to standard deviation, and also we use the Nash Philip efficiency. The Nash NSE is a metric that is borrowed from hydrological model frameworks. It's basically used, the NSE is basically used in hydrological frameworks to quantify biases and variance in hydrological models. So for the RSR, which is the ratio of standard, ratio of error to standard deviation, and the NSE has the table here to quantify the range of very good and not so good. For the NSE, it is between 0.75 to 1, and for the RSR, 0 to 0.5, and below that, it is in the good, low satisfactory, and not so satisfactory. So for the first objective, we found out that the PM2.5 do not correlate well with the in-situ device, and it has a correlation of about 0.7 to 0.3. For PM10, it's about 0.6 to 0.3, and an error between 44% across all locations. For PM2.5, it's about 40%. It is above 40% for all locations. And particularly for the Mabaya location in figure B, in both figures, shows that it is very high. The camp data overpredict in this location. So after calibration, after testing and training all the models, we found out that the random forest regressor performed well for 2.5 and achieved a NSE of about 0.8 to 0.91 across all model and achieve Pearson correlation of about 0.9, 0.96 across all the models. For PM10 also, when forest also achieve exceedingly performance across all the location of about 0.96 for Pearson correlation, and also an error of about 2.1 to 6.89, which reduces error drastically across all the locations. So this shows the performance metrics of all the models we use. The first one is the Pearson, where the random forest achieve best results, and the MAE, mean absolute error, the MAP, mean absolute percentage error, the RSR and the NSE, in which random forest achieve very good results across all the metrics, which is followed by SPR, which also achieve moderate gains, but not so good to the random forest. And also the multiple linear regression and the linear regression model were not able to achieve a higher metric, a higher performance. And the reason why random forest work best is because it was able to find out the non-linear relationship between these variables and PM 2.5 and 10. So the limitations, of course, we acknowledge limitations is that the first one, we use a 3-month data set. Second one is the CAMS data set. We values at 2 times in a day. The third one is that we use 4 locations, which might not reflect some locations in Lagos, as some locations have their own microenvironment. And the significance of the study is that it proves that this framework can be used in calibrating global models to enable and show that we can get a near real estimate using satellite data, and it shows that in-situ devices are not just for validation, and they also serve as calibration. And of course, the future world, of course, is that we'll be using a longer training data set, and also we can scale this framework across different locations in Lagos and across Africa. And also we can also use this framework, of course, because of course the CAMS data set is integrated across various early warning systems. By calibrating, we can improve the reliability. And also for the last one, this concludes in conclusion. The conclusion, it shows that all CAMS data do not actually correlate with instituted data and does not really reflect what we are really emitting. But when it's anchored in random forest, particularly machine learning calibration, because there are also other machine learning models that are better than random forest, and it is grounded in instituted data and methodological variables, we can achieve a equitable air intelligence by getting near real estimate of satellite data. And this work with this global model and hyper-realistic monitoring in the global south. Thank you.
We just managed to hit it at about 15 minutes. Right, thank you. Like I said, we will now take questions. You can stand there. The others who have presented join. Using the super network. So then, and then we'll ask questions. You ask questions. If you ask a question, you will direct it to question to any of the presenters. And then we take note of the question. After this, did what? Okay. Okay, to help us move. So after this section, we'll just set our leg for 5 minutes. You stand up, you can stand up, move down, yeah, move down. Let's walk. Sorry. Stay head free. So, so how many want to ask questions for which presenter? So, don't follow that. Online. Okay, somebody wants to ask a question online. Okay.
I work around 12 hours. Some of my cameras, guy has a guy from 12 hours in the glass box. Right? Some days I'm asking for a while. I walk out of the gravel lines. Two voltage on two seven companies. The glass spot out of it. See, two hands. Two simulations when you hire a lady that's right through the rest of the don't turn the truck on the gas costs. See, I can pull my.
Is it the person?
Since my arm is. But as soon as I lose myself, I'm walking. I sat in front staring at the whatever. I couldn't even feel my fingers going up. So I almost called my lawyer.
Is it?
Right. Yeah, I think it's a distraction. So I'm going to read out the question provided by Dr. Stephen Ogupero.
Oh, okay.
So I read, fantastic presentation. I would like to understand whether the author has conducted original research on digital twin technology. So I think it's on a person who reported on that beyond a general literature review. From my own observations, there has been a noticeable increase in research activity around DDT in recent years, particularly in applications related to climate and weather, which you referenced in your presentation. Could you briefly explain what digital twin technology entails in simple terms, methods, and why it is important that we consider adopting and exploring this further? So I think this is a question for
Bridget.
Yeah, Dr. Diagi Bridget. So please note that, Dr. Diagi, so that we'll give you the opportunity to provide an answer to that. I can see a hand from Dr. Awoleye Peace. Awoleye Peace. I hope, from South Africa. Yes, please go ahead with your question. Thank you.
Yeah, thank you. I can't type my question because it's just a lot. So my question goes to the second presenter, I think. Yes, that was the one talking about the machine learning thing. Yeah. So first of all, the machine learning thing, I'm not sure if you can use only the RMSE to say the machine learning performs better or not. Because literally in the methodology, you can't use just one metrics, most especially RMSE. No, it won't capture some of the observations that you are ought to capture. So I would suggest that you go further to use the bias metrics, because I noticed your data set spans for like 3 years or so. So your RMSE won't tell us exactly how the model performs. That's number one. And also number two, machine learning thing, it's somehow, because the thermodynamics that you say you are trying to capture in the machine learning, to be honest, machine learning AI models, they don't resolve thermodynamics equations in meteorology. No, they don't. So what resolve these thermodynamics equations are the physical models, the WRF, the RxCM, the ICON, and a couple of them. But here, AI and machine learning, they don't. What they do is just to create like a representation, like to mimic what the thermodynamics supposed to look like. So, but one condition is that if your AI or your machine learning is physics constrained, then fine, you can speak to that. But I'm not sure your machine learning is physics constrained actually. But if it is physics constrained, then your argument might be right, just might be right. But if it is not, then the dynamics rather that you say the machine learning captured or you used or something, I'm not sure if that is correct, because they don't actually resolve the Navier-Stokes, the Newton's second law and all that, they don't resolve it. It's the physical models that do resolve those thermodynamics. So I don't know, maybe you did that, or maybe I missed the slide from it, or so, but I'm not sure. So those are my two observations. If you don't use physics constrained method, I would suggest you do that because it can actually improve the model output. Yeah, it can improve the model output for you. But if not, maybe you should consider it. Yeah.
Thank you. Peace.
Thank you. Is there anyone who has a question, either virtually or physically?
Thank you very much. My question is for one who work on media production. Media production. Thank you very much. It's a very nice word. I want to know if you work only on one variety or use different variety of media. If you work on only one variety or different variety of media, according to the agroecological zone.
Okay, no, just take, we're taking note to work. If you can.
All right. Let me ask Bridget Diachi. I think it's the second time I'm hearing her present somewhere.
I think she presents
at the mapping, using machine learning and all this to look at publications, pathways, the strong universities, the weak universities, and so on. Very, very interesting. I just want to make an appeal to her as we need to work collaboration. When we look at meteorology as a society, we are interested. Which universities are doing well and in what area? In core meteorology or related aspects like environment and so on. Can she do this in partnership with us? Because in NMetS, that's the General School Society, we want to know our strength. In fact, if she can also do it in terms of demography, that's fine. What are the old ones doing? They're just doing things that are cake. What are the young ones doing? Are they really migrating? Are they publishing? What is the focus? And if I may ask, universities are now interested. Where are you publishing? Are you publishing in Q1, K2, Q2 journals, or in journals that are not visible? These are the things we take colleagues and it's like, oh, what are you talking about? So she can do the mapping and it will be very nice. But for me, can you map out the General Medical Society for us? We want to see the strong areas where we are flourishing and the areas we are lacking. For example, energy meteorology. We are looking at, so many things, even the complications in machine learning and AI and so on. It will help us to go back to ourselves and say, what can we do better? And mobilize our youth so they can key into something. So it's something that we want to discuss for the society. Professor Kone also has something to say. Would you want to say that? Okay, later on. Yes, so there's a need to contact Oscar because Oscar is also interested to map out some things. And the international person is here. So it's a collaboration that happens all the time. Thank you very much.
Okay, any other question? Okay. Sorry, you are taking your own exercise. We are asking.
My question was Sister Okoye ginger production. How you connect your data across those I think the both climate data and the crop that is the ginger. How do you connect the data? Then number two, I want to know. Maybe I should just read back. Okay. Now, I want to know, are you focusing on production or yield? Okay. You know, there's a difference between production and yield. If you are focusing your attention in production, with the total amount of harvest, it can be cloud the impact of climate on your work, because it means that you are just looking at the way the production increases with the land put into that production. It means that, you know, the production increases as the land put into production also increases. And if it is like that, you know, it will not allow you to see clearly the impact of those climatic variables on the production. You should know the difference between production and yield. You know, yield is what is important, because yield is the rate of production per unit area. And, you know, that is what is more important. So I want you to note that. Then number two, I also want to know, you focus on ambient temperature, that air temperature alone. I want to know, why are you focusing on air temperature? I know that rainfall temperature, they are the crop determinants. They determine the production of crop in the tropics, where Nigeria is. But we also, you know, a lot of studies have shown the importance of soil temperature on crop production as well. Like that ginger, if you know the depth that the root grows into the soil, you can now take the soil temperature to that depth. You can start maybe from centimeter to 10 centimeter to 20 centimeter interval. You understand? And you also consider the effect of these changes on the yield of ginger. And the first person that asked you question, you know, they not really allow me to dwell more on the third question that I would have asked, because I discovered that I plant ginger and a species of ginger, but by the time I harvest, I discovered that you know, the one harvested is not as the one planted.
Yeah.
You know, most especially the way it tastes in the mouth. And I planted the one that is very sharp. When you taste, it's very sharp. But when I first, I've planted 2 or 3 times now. I have planted this year again. Each time I harvest and I taste the one that I've harvested, you know, it will taste a little bit bitter and not too sharp, like the one I planted. Maybe soil factor has something to do with it. I don't know. I've not studied that. So since you now talked about varieties of ginger, I don't even know that we have varieties of it. So maybe my question will hide under the fact that there are varieties of ginger, but it will be good if we know the reason the quality changes, you know, when you plant and maybe it's because our soil, I don't know.
Thank you very much.
Yeah, I think
Since you are president, Madam, you can add that to your future work. Because my wife had
ginger in our house and own opposite our house. And what you said exactly happens. What you plant, what you get. In terms, even the color, the same to them. You can plant yellow turmeric, and what you get will be something that looks pink, like. So you might find out. That means you are now going to do not just the yield studies. If it's yield studies, it's different from all that. But if it is production has to do with the phenological development of the crop, which I'm talking about the effect of the parameters on the various stages of the trees, from the time of germination to the time of something as flowers to the time of mature. So things you need to take the seed and go to the lab to examine the soil and look at the chemicals of the soil and different plots, and then so that is a good start. But most of what Professor Lariwaju has said, and what my wife also experiences in, so it's a good thing to look at. I think, is there any other question?
Yeah, the question.
Sure. Oh, okay.
Thank you very much. The one was in the presentation on air quality. You stated a period of study. What influenced it over? So I wanted to know that, because we know season impacts air quality. Why we did do a season for study? And what was the air quality for the air quality value, and for that of what you chose from the salad? I wanted to know that one. Thank you.
Okay.
Yes. Question is, you recorded air quality for readings from the mirror sensor, and one is the error factor. So what could you tell? Was there similarities before you did like preliminary tests of what's yes? Before you for further analysis, you are supposed to check what they are before you conduct further. If they are similar, if there's some differences, error with your data, it did calibrate with other sensors with the NMetS standard. Also, you didn't speak about all those sensors, so I wanted to find it.
Okay, I have a question for a couple of presenters to Dr. Bridget, Dr. Diagi. I want to find out.
Still read out the question before you respond.
I want to find out if you used the PRISMA framework for your review. I would like to know, because the use of the PRISMA framework will actually improve the output of your study. And to Dr. Okoye, the climatic classification you had for Nigeria, I was expecting that you would use an agroclimatic classification or an agroecological classification, because the first classification is quite, it's not as specific as when you use the agroclimatic, since what you're looking at it's kind of climatological as it relates to agriculture. And I want to feel, or my opinion, that the use of agroclimatic classification would be more specific and will give us a better output to what you are studying. I think that's what to say about it. Thank you. So to the various presenters, I'm going to read out some of the issues or questions or comments raised. To Dr. Bridget. Dr. Bridget, are you still there?
Yes, please, I'm here.
All right. Were you able to get all the questions, or you want me to read it out again?
Yes, I was able to get few of them, but if you can assist me. So let me just go first with the last question. The person that is asking if we use the PRISMA framework, I know that in previous studies we have adopted that, but for this particular study, we didn't look at that. Okay, but if you look at some other publications we have done, we have used that. And so basically what we're looking for, the bibliometric system was just able to give us what we needed for this particular paper. So we didn't go that route for this particular paper. So the other question on, I think, is on how we can look at how institutions are faring, probably in the area of publication, and how the younger generations are also faring. If you remember my conclusion, I said this study helped us to look at who is doing what, where is it being done, and with whom is it being done. So this system can actually help us to also look at that. Where are people making their publication? With whom are they making their publication? And in the areas that they are making their publication. So I would say, yes, it's a tool that can help us, to do that. Those are the two questions I think I can remember vividly. But please, if there are others, you can please help me to read them out. Thank you.
Yes, there's a question on the chat box. Okay, before going on the chat box, it's answered the question of the President Amendment S. He was also asking if you can do a collaboration because the society wants to know the strengths of researchers in various, particularly meteorology and climate studies. So maybe you can reach out to the president, and then I think Dr. Bridget, you also presented a paper like this.
Yes, in 2024.
Right, I can remember.
Yes, yes.
Okay, so and also Pascal also wants to have that kind of integrated outlook of how the various. So you have a good, if you can maybe reach out to the director of capacity building, is that what? Professor Code will get out to you. So, okay. Prepare.
To be an honor, sir.
Okay. Yes.
Okay. Dr. Peter Awoye asked whether ROMSE is sufficient enough to test or to create the model performance. Now, there are other metrics by which we can actually evaluate the model performance. RMSE is the most popular, followed by MA, which is mean absolute error. Now, like this work is not exhaustive. It's still open to further. While ROMSE is not the only metric, it's one of the best metrics. Why? Because it brings down outliers. For data that is, let's say, extreme values, it tends to soften such effects across entire data set. Now, whether we consider the physics-based equations in working with the models, now the answer is that models themselves do not attempt to resolve physics-based equations. That is why they are called machine learning, because NWPs are designed to resolve physics-based. So because of the chaotic nature of the atmosphere, machine learning simply learns from the past. It doesn't necessarily follow equations. Y equals to mx plus c is physics-based. So you can resolve y when you are given m and x plus c, you can resolve y. But for machine learning, if you ask machine learning what is y, it will tell you what was y yesterday, what was y day before yesterday. It will now tell you what the y you are looking for is. So while my answer may not be very exhaustive, I'm open to further discussion on this. Thank you very much.
That's so much, bro. Yes, I use only one variety changer.
remember I took that I collected the crop yield data from Nigerian Bureau of Statistics. So it's one. Thank you for yes, yield. I worked on yield performance. Thank you for the
sorry, even on yield, what is the
growing period?
The growing period?
Yeah, for ginger. Because if you are going to use
climatic data for the whole year, whereas the plant ginger in December,
in June and harvest in November.
Did you take consideration that climatic data was starting the period of growing in your data? Did you take that?
The experiment was not carried out by me. It is a secondary data. So I don't know the period that it was planted.
Sorry, you got to that search when even when ginger, and now you are using ginger from different climatic zones. When the name plant in those different, we're just trying to make what will make your work to become more real. Yeah, more of us. When are they planting in those climatic zones? That's when the rain, when the plant went there harvest. That's when you're asking for the climatic data, that range of period. Okay? That's number one. Then when you are then I discover also that your plots, there are a lot of vacant space. It does not allow us to see, for instance, your rate of scale on the y axis or whatever. Makes your hanging up. So it does not allow it to flow. And then we don't know when they are talking about methodology, about results. It's lumped together. That's what I'm saying. Because sometimes so I think of a fantastic job, but model up. Is that the other question? Yeah.
Yeah, the difference between the mirroring and satellite-based airport forecasters.
The question on the correlation between the method variables.
Period of study. Why you chose
period of study? Yeah.
Period of study. Yeah. Period of study is from we used to read on data which is from October 1st, 2025, December 1st, 2025. This it was done actually in early January. So data was what we have as our use.
Were you trying to capture any season, any peculiarities in the period?
We captured the transition by season 2025-2026. So for the future of our study, we use annual data set. We have to capture both the dry season and the wet season. But for the study, we only use the data set that capture transition into the dry season, which is the October, November, and the December.
So how about the difference between the movie and satellite-based quantifiers?
Difference.
Did you notice any difference?
Yes, if you notice difference, it can be shown in the result that the air and cider have varying difference in terms of the correlation. They were not able to correlate well. Sometimes the CAMS data
bias.
There was a bias, the data. So the CAMS over predict and under predict across the different stations that we used.
So Mary sensor, what was the calibration standard for the mining? Because you have to calibrate it with what is accepted. Was there any calibrations
or maybe
action ratio you added to make sure that it was recording as the NMetS standard or the NMetS sensors were?
Okay, for the calibration of maybe that was what you are. We did the calibration for the maybe air. We will use the reference instruments such as the BAM ones that were 2.0, rapid device here in Lagos, we did it. And also we did the calibration study in Africa, Ghana, which shows that our device are calibrated and can show reference instruments.
So whether we record same values as the one NMetS has already set up, or there was differences from
Actually, we not use NMetS devices for calibration.
to standard to show if it given the exact.
Yes, we use standard. We use standard. We use the 1 level, 2 level. Yeah.
That's case. Where do you reference your calibration to?
AfriSet.
What?
AfriSet.
AfriSet. What?
Ghana.
AfriSet.
Performed very well.
AfriSet accepted by NMetS.
So let me speak for NMetS. Okay, so for NMetS does not have very dense observation network. In Lagos, we have two. I'm well aware of. That's what you have, that's what we will show you. But based on the location that he's talking about, but NMetS has been used several times for research studies. Okay, so this disparity is a source of concerns. So what I would suggest is you use how many years? 3 months. 3 months for.
It's 5 minutes.
Yes.
5 hours.
So using 3 months or 5 months may not be sufficient to have a very logical conclusion about whether this is to be used or not to be used, because CAMPS has been used for a very long time. Okay, and really just coming up. And I want to suggest that let's continue to observe over time. And then calibrating it against AfriSet, we need to have some documentation against about that. Why AfriSet is the reference point? Who are those that have used AfriSet as that reference point, so that whatever you're doing is authoritative? AfriSet can be a random thing. Okay, is it peculiar to Lagos? Where else has it been used? Is it good enough for our terrain? Okay, so what I would suggest is that continuous studies should be carried out. So when we have some good enough sample size, then we can put our foot to the ground and say that, okay, yes, this is good enough for us to use for studies. And then, at the end of it all is, we can recommend, we can develop policies, we can use this information and apply it to an environment.
Even for their what they calibrated against, the national calibration is what is accepted by WHO. So if it's not, at least they could have set up a center at Yaba so that at least for a man to get it to the standard NMetS that before I think go into the other standard states, so they get that right calibration.
Yes, Pat, yeah.
Thank you for your contribution. So AfriSet is a regional calibration team. And AfriSet that has to be precise. So when you look at the alliance, and we also have a calibration center here on the so we could,
your voice is not coming out.
We collocate and we calibrate our devices from. For the essence of this work we are doing it so that we can use our data. If we are just starting out, we have data short period of time. Yes. So this is just direct studies, and we are still working.
So it's a work in progress.
Yes.
It's not like a final study, and it's a work in progress.
What is actually in calibration? If AfriSet has been referenced an international or national standard that's acceptable, I should say, you can reference that AfriSet has calibrated reference, so that's acceptable. But people must know where your calibration is coming. All right, what's that? I think that's done. Okay, I think we are through. But is there any question?
Yes.
I always tell you that.
Well, what is that?
Please, I think they want to respond to me.
Please, you want to as enough.
Hope your hand is up.
Sorry, it's for the machine learning guy. Sorry, it's for the machine learning guy. Yeah, sorry. So, when you say machine learning or AI can't resolve thermodynamics, no, they can't. I said it initially that there is a part of physics constraint aspect. So you can actually tell the model or whatever to resolve those thermodynamics. But trust me, it's not something you can get done in a day, 2, even 1 month. In as much as we say machine learning is fast, AI can speed up things, but still, it has some of its limitations. So most people run away from trying to use physics constraint approach because it's actually expensive and it's not as fast as possible. So if you are looking at future work, I would advise you should just start, to work on physics constraint aspects because that is when your AI or machine learning can actually give you good and better results. Yeah. Thank you.
Thank you. Thank you. And we are still online. I think Dr. Bridget has a question on the chat. I think you can see it from Dr. Gubero respond to it. Maybe that's the last now. Dr. Gubero is from the Republic of Ireland. Bridget, are you still on? Dr. Bridget?
Yes, please, I'm still on.
Are you seeing that question asked by, that was the first one that the rapporteur read out?
Okay.
Are you seeing it on the chat?
Yes, I'm trying to read the question.
Okay, please read and respond to it as the last, and we'll close the session.
Okay, so he wants to know what digital twin technology entails and why it is important in climate change studies. And so from my work, we see that digital twin technology is like a live computer copy of a real thing. Maybe what we will call a simulation, okay? So it gets data from the real world and tries to show what is happening now, how it has happened and where it is happening. Now, its relevance in climate change study is because it helps us to kind of link the real world observation with high resolution simulation model and make it possible for us to study how our Earth system kind of responds to changes, either in an interactive way or in a predictive way. So it is very valuable, to studies that have to do with climate change, sustainability of the soil and Earth-related study. So I don't know if the person that asked the question, if he's in the hall or is joining from online. So basically that's what, the digital twin technology can help us to achieve when we are looking at climate change studies. Thank you.
Dr. Kubera, are you still online? Dr. Sid? Okay, so.
Yes, thank you.
Okay.
Yeah, that's okay. Thank you.
All right. Thank you. Okay. A round of applause. So, take picture with. No, I think okay. This batch, you take picture. Oh, okay. Okay. Batch 1. Okay, batch 1. And batch 1. Batch 1. Batch 1. Ah, no, right. Stephen and Bridget, can you put your picture on? Oh, okay. Yes. Okay, I'm moving. Let's see what we do, Master. Let's put your big. Okay, right. This one, let's have it. Good. So, yeah.
Yes. Yeah. Except the she doesn't. Yeah. See better. The better. Yes, the better. See better. The science of with that can planet Mars. Okay. Thank you. So, 5 minutes. Or 11 Sorry. We can come back again. No, we're not going to. Just stand up. That's all. Start the session. We'll go for lunch. It just helps. It just helps. Because my smartwatch has been telling me to. And I will flow in this. Just stretch your leg. That's all. Then when we start, just pray. What's that? Okay. Say after some play. Yes. Okay. And if you want to look at go to the restroom, that is fine. Slide it down. Just for this session. Who is stepping out? No. The shaman's like, okay, we can start. Okay, well, my break is coming. So we are starting batch. Happy batch 3.
Who is coming in first?
So Kenny is coming first. Then after, it's your own there. Then it's a lot. Then like you. But we call it like that. Yeah. Because you know, all the music wait for the studio. Yeah. Okay, let's okay. Yeah, I don't use this. Okay.
Please, can you unmute the main speaker? We are not receiving you, those of us that are online.
Please, Professor Steve. Professor Bimbo.
Yes, we can hear you now.
Okay.
No, I think we're not hearing the main speaker, please. Can you unmute?
Maybe you have a network problem. It cannot be a general problem. Somebody said they are hearing.
All
Okay,
right.
let's go. This is my type.
Can we continue?
Yeah, they are hearing. Maybe let me use my type. Okay, thank you very much. So we move to share and also we come back to give value to what we are doing. And this is a part of the methodology. Again, one of the key methodology also, before with that, okay, the strategy to go for that, when we finish the selection, train the student, we finish the lecture, what we do is how we design the topic for the student. And now the design of the topic, we have a tentative topic developed by the team of the directorate, where after the development of topic, the student will work on the topic to develop proposal. And we validate the proposal through the kind of collaborative discussion between the director, the team of those who are leading the program, our researcher at Competence Center, and then also the people who are members of the advisory board committee and other supervisors. This is where we refine the topic of the student and then they will develop the proposal. And then after developing the proposal, the same search topic identification, proposal validation, and then the student will go for data collection after the release of form. What is specific for this situation, WASCAL, is the fact that one student is already supported by three persons. One is the main supervisor coming in from the university. The second one is the German, the co-supervisor who might come from the country of the student. And then we have a German partner. You see, we can say one WASCAL student is really well surrounded by the team who is helping him also to or her develop a nice proposal and go for the publication, go for data collection. We monitor the thesis. We have also the deliverable, the student, every student should know I have the thesis, document, publication, the policy brief, technical paper, and what is required for this batch is the thesis document, publication, and the policy brief. And then the student can moving for the data collection, the student will be continued to be supported and then go for the defense of his proposal through also a roadmap we have already designed for those people. You have a roadmap for the master program, semester 1, semester 2, semester 3, and then semester 4, where they have the defense time indicated. So for the basic program, the same also activities, they have to go through a program we already designed them. And it's not we sitting at the headquarters design, but we design and we send to them for the validation. And if you see after the course and also, sorry. Just can remind me if the time is running. So after the proposal validation, where it's supposed to be it's a month, for example, we give them 6 months for every cohort, and they have to go for a 2-year data collection. And during this 2-year data collection, they will find a way to go for Germany for 3 to 6 months for the collaboration for the scientific visit in Germany. It's not mandatory, but if they can find a way to go, it's also good for the student, for the networking, and also to have application our partner there. So at the end, they have to come back at least 10 months before in a graduate study program for the thesis writing and the proposal. This is how we do the methodology we do for all the students, go through from the data collection until the defense of the thesis. For also the master program in hydrogen, we have also 2 semesters running in one place to do fundamental courses and also fundamental courses in hydrogen. And then they'll go for the 3rd semester, different country. And at the end, they will go for 1 year training in Germany, and 2 months they come to do the defense course university. This is for the master student in hydrogen. So what we got in terms of founding is the fact that we have all the training. If you take the countries, we have the number of students who have trained from the 1st and the 5th batch in a different country of WASCAL. And we see here also where we train our methodologists. And those are very key because we know in the next years coming, they will support WASCAL in releasing data to our students. So all data are not methodological data. We talk about socioeconomic data. We talk also about other data who are very relevant for the students since they are working in different areas. And we have been able also to train up to 655 students for the whole. And among these, we have 136 students in our energy program. So those students are started working already. Some are in PhD for the master student, but most of the PhD students are already shared that they're saying that it's easy and from easy and how easy it is for them to get job. They are mainly getting job at least 70% from the 6 to 12 months after graduation. So what we have also observed when during the selection, you see we have already enrolled at least 728 students. Among the 700, we have 222 who are female. So the training of female, so something was called or really was called about it. And from each batch, we started in 2020, 11, the batch 1. The total selected was 60 students. And you see, according to the number of years, from 2012 to today, where we did the last selection in 2025, the number of students have really increased from 60 to 156 students. And this is because also the number of graduate study program established is increasing according to the country who are doing WASCA. And this is also very important to know. And among this year, you can see also if you take the number of graduates, how many females. You see, for example, we selected here 60 students. We have among these people who have been selected, we have at least 14 females, and all of them have been able to graduate. And the number of females also has been increasing across the batch from batch 1 to batch 6. We are currently having 54 students selected for this current batch, and this number was 53 during the last batch. So this is how also WASCAL have a strategy to see how we train more females in our graduate study. One of the figures for the last batch 6, you can see we have the number of students here, and then per country, how many females have been enrolled for this current batch. You see in blue, except Guinea, where we have only 1 female, we have, it's not 0, it's 1 female. The number of female is really important for this current female batch. We have, for example, in Cote d'Ivoire, 8 female out of 12 students. And then we have 7 students in Burkina out of 12 students. The total is 12. We have, for example, in Futa, 5 female out of female, meaning that we are beyond 30, but 30 is not our expectation. We are around 35. And for the next batch, we are targeting 40 female ESP out of 40% of female in ESP. So this is also something we need to strategize, and this is what we are doing. And the rate is here, the number of female, and the rate is here where we have at least from 58 to the maximum and 20. In Guinea is not 0, we have 1, so we found 1 after. So then where people are working, mostly in the university, we have about 29%. In academic, the research are 17%, and also for the ministry, 8%. If you see those three, we have at least 50% of the students working in academic and research. This is also something very relevant. Most of them, some of them are going for the postdoc. PhD are 18% for the master student, and also some are working with NU. So to say that WASCAL is really thinking about not only graduate people, but taking into consideration the participation of female students in our graduate study program, and also they can also contribute to scientific research and also scientific output, and then also contribute also to the social economy, improving of the life of community. So we do that through the collaboration with institutions in Germany, and for student selection, supervision, short courses, and also for proposal development. In conclusion, what I want to say on the way forward, WASCAL has an excellent center in terms of education, who can also be an excellent center for Africa. And there they are also using different strategies. Among them, we have the use of artificial intelligence, also to see how this can be used to accelerate also some data dissemination and climate action also. And also we are working to expand also the program. And then we have also this this response of WASCAL to the research, the scientific research, and also to response also for climate change for the country to see how they can use those lessons to tackle the issue of climate change. And we have also what is missing is how we can get a strategic plan for sustainability, because we have a support coming from Germany. What we think now is one day we know the partner will not stand forever. They will drop out one day. How we can get a strategic plan? We are on that discussion, elected to see how each program can give us a strategic plan for sustainability. So I want to learn. Thank you really for bringing me on board. I hope. Thank you.
Okay. Okay. Are you following the watch the crowd? Let me know.
Show her my son.
Okay. But my name is Peter.
Yeah.
Now for it. Good
afternoon, everyone. My name is Odua Bukola Babalola.
Your time starts now.
My name is Odua Bukola Babalola. I am the meteorologist at Nigeria. So the title of this work is Meteorological Influences on PM 2.5 variability in Lagos, Nigeria, using an ensemble of Miri Air and DRP-WACS analysis data. So by now we should all be familiar with the term PM 2.5. PM 2.5 are microparticles that are less than 2.5 micrometers, and because of their smallness, they enter into our lungs and different parts of the body. This image shows how small PM 2.5 is. So we can see here the relativity of PM 2.5, PM10, and even sun. And this is the human head. So these smallness make them very dangerous in our community. So PM 2.5 poses severe health risk. And even according to the report that was released last year by Clean Air Fund, they said that PM 2.5 is one of the leading causes of death, especially in Nigeria. So also meteorology influences the dispersion, the transformation and accumulation of the pollutant. So the critical gap that we are trying to fill by this study is to carry out a survey. It's because in recent studies, there have been few studies that integrate ground-based sensors with satellite data or even just ground-based sensors. Most of the studies have been with using satellite data and not ground truth data. So that is the essence of this. So the aim is to examine the spatiotemporal variability of PM 2.5 and how meteorological variables influence it. Our objective includes to measure PM 2.5 variability across 3 urban typologies in Lagos, identify dominant meteorological drivers using ground and reanalysis data, and to characterize diurnal patterns and high-risk pollution stagnation hours. So our study area, like I said earlier, is Lagos. Lagos is the most populous city in Nigeria, and this Lagos is also a coastal city. Because of the population, there has been a lot of vehicular emissions, which contribute to pollution. Then there's a lot of industries around here, which also emits different pollutants. So the source of our data is our NMetS stations. My colleague discussed earlier, we have a network of monitoring stations across Lagos. We have about 100 devices that are already tracking air pollution in Lagos here. And so we use a combination of our ground truth data with satellite data. We obtain data for PM 2.5, temperature and humidity from our stations, and then we combine them with wind speed data and boundary layer height at a 31-kilometer spatial resolution. The monitoring period is between the month of October of 2025 to January 2026. This period is particularly because of reduced rainfall as it tends towards the dry season and the peak of the season. So for our methodology, because we assembled this, we did statistical analysis, we did different processing, and we used Python for our analysis. I'll just move on to, so this is what the this is what the platform looks like. You can just select whatever data you want from wherever point and get your grant data. So here are our key findings. First of all, PM 2.5, this graph shows the variability of PM 2.5, and we can see that from the month of October, PM 2.5 began to increase, the pollution level began to rise, which is owing to the dryness of the atmosphere and the influence of the northeasterly wind that carries the dust, and then the Harmattan period. And so we can see that the highest month that has the most pollutant is between December and January there. And then looking at different places across Lagos, Ikorodu shows the highest concentration of pollutants, and that's because Ikorodu is towards the northern part of Lagos. It has more industries, and then because it's closer to the north, there's the influence of the northeasterly wind. And then this is the Lekki Peninsula axis. This axis is close to the ocean, and so we can also attribute the influence of the ocean on the reduced pollutants in that atmosphere. So now to the diurnal pattern of this pollution. we'll see that towards the early hours of the day, between the hours of 5 a.m. and 7 a.m., pollution levels are elevated. And then the trend slows down during the afternoon, during the day, and then towards the evening time from 4 p.m., the pollution level begins to rise again. And then our peak pollution is at Ikorodu, and the least pollution is at the Lekki Peninsula, which is the BI, Ate, and all that area. So to the influence of temperature on PM2.5, we can see from here that the correlation shows a negative correlation. So when the temperature is low, PM2.5 peaks. And while the temperature is high during the afternoon period, the PM2.5 level in the atmosphere reduces. And we can see that trend again happen towards the evening. It begins to rise while the temperature drops. And then we can see the same process occur all through the study area. Yeah. And then one thing to note is that from basic meteorology, we learned that warm air rises and cool air sinks. So when the temperature is high, when the air is warm, the pollutants can easily rise and disperse. But when the temperature is cool, pollutants can sink. And so this is also a process that's happening in this place. Thanks to the influence of humidity of PM2.5, according to our statistical evaluation, we can see that humidity and PM2.5 have a positive correlation. And we will see that when the humidity rises, the level of the pollutants in the atmosphere also rises. When it drops, and when it peaks again, it peaks. And that's because humidity influences the size of the particle. When there's moisture in the atmosphere, this tiny particle can come together to form bigger particles, which is what we call the hygroscopic growth. And then, yeah, this is it here. Hygroscopic growth occurs. And then when these particles become moisturized, they become heavier, and the wind might not be able to move these particles. That's the layman term. So we can also see that peak humidity aligns peak period of PM2.5 in the atmosphere. Moving on to the next slide, we showed the influence of wind on PM2.5 in the atmosphere. And we can also see that these two, PM2.5 and the wind component, have a negative correlation. It shows that when the wind level is low, the pollution level peaks. And when it is high, when it is high, dispersion occurs. Because of this, this is a very key component in pollution studies, because once the wind level is lower than 2 meters per second, once the wind speed is lower than 2 meters per second, it shows that there's not so much movement in the atmosphere. And when the level of pollutants is high at that distance, there will be no dispersion, and that can cause a great impact on human health. So we can see that happening in several cases here. You see that this wind here was lower than 2 meters per second for an average of 6 hours per day, which means that humans were really subjected to a high level of pollutant concentration in the atmosphere. And then, okay. The next point is the impact of boundary layer height on pollution dispersion. When the boundary layer height is low, when the boundary layer height is low, the pollutants are close to the pollutants level increase. And then when the boundary layer height is high, the dispersion occurs. So the humans are not exposed to that pollution to a large level, to a large extent. So The boundary layer height shows strong diurnal control of PM2.5. And according to this study, we saw that boundary layer height has the most influence on PM2.5 dispersion in the atmosphere. So Ikorodu it has a negative correlation, which explains why 53.3% of, which explains 55.3% of variance. And then pollution trapping conditions occurs like an average of 7 hours. But one thing to note here is that for this region, it has a lower level of pollution, and then the influence is lower because there's the prevailing wind, there's the wind from the Atlantic Ocean. This is a coastal community, the Lekki Peninsula. So because of the wind from that region, the pollution doesn't grow to an extent that is as high as these other places. Then Agege, you must note that Agege is a highly industrialized community in Lagos, which also explains why pollution levels are high. I'll just move on to the next slide. So in summary, PM2.5 shows strong seasonal and diurnal variability. Bear in mind that this study was taken during the period of lower rainfall and Harmattan, and it also shows that Harmattan significantly increases concentration. And then I mentioned earlier that boundary layer height is the most dominant influence on pollution dispersion here in Lagos. For further study, we can also carry out another survey during the wet period, so we can compare and contrast what happens in those two seasons. Thank you.
Okay. Okay. The rapporteur is now presenting. I don't know who will go to rapporteur. Yes. Yeah. Come on, rapporteur for the topic. I want them to. Mikey. My phone too. I've written my name. Okay. This week, let me get the yeah. What is this? Okay, your time starts now. Oh, sorry. God bless you. Yeah. That's it. Okay, go to the beginning. Don't go there. Don't. Listen. Okay, got this one. Okay, this is a cookies. So that hospital is with about to just to no right. So when we're asking questions, we're going to catch questions. Are you set?
Sorry, we can't hear you.
Victor.
Please confirm if.
Yeah, it's fine. It's fine.
Okay. Now, West Africa happens to be a very unique terrain. We know that it is highly exposed to climate variability and extremes. And we also know the challenge of sparse and unevenly distributed countries observations. And we know that three-world impacts often interact or arise from these interacting extremes. And most of these climate risk assessments have been carried out based on single variables. And so there is a need to know that these interacting extremes remain well less characterized in this region, why we need to have this study. All right, so I'm talking about the interacting extremes that produce these compound events. There are various interacting extremes or compound events. For example, we have the heat and drought and heat waves, the heavy rainfall and urban flooding, heat and air pollution. These can move together, and a single climate extreme event really drives climate risk. It emerges as a result of multiple stresses. And so there is this challenge that interactions are often the least observed and the least understood. So yes, we say that West Africa has issues with data observation, but it's not just about data observation, but missing data, inconsistent data. So because of that, we do not have this clear picture of how these climate extremes interact across space and time. And in West Africa, climate variability, especially the aspect of rainfall, is very, very important, and it can be devastating. We also have issues with heat waves. And when they occur together, it brings up a very high risk. It's because we have a different picture or scenario fundamentally. And so we need to look at these extremes as they combine together and not in isolation. As I said earlier, we often look at this, we often consider these extremes in isolation, but we need to look into the whole occurrence of these situations. And so we look at the climate extremes, vis-a-vis, or the compound extremes, the missing piece. As we can see, there is limited long-term analysis of compound climate extremes in West Africa. And yes, we've made attempts to look at satellites and reanalysis data sets, but when it comes to the concentration of compound events, such studies are limited. And then we also have the issue of limited spatial information, especially as regards the characterization of where these risks are located or concentrated, the characterization of heat-drought interactions, and how these compound hazards are organized. So we need to have this clarity on whether the compound heat-drought risks are spatially uniform or they are regionally structured. And so this leads to some basic objectives, which are three in number. That is to look at the spatial temporal distribution of climatic anomalies in West Africa, to identify hotspots and clustering of the compound hazard events, and quantify the severity and the frequency of the compound hazard events. And so we are looking at West Africa, which is categorized into the Guinean Coast, Sud-Sudan zone, and the Sahelian zone. And much has been said about the peculiarity of West Africa. And so we used the James Precipitation Era 5 for the near surface temperature and the ES8 soil moisture, just look at the soil moisture. And these are categorized into standardized anomalies from 1981 to 2024. And an overview of the methodology, like I said, the climate variables were standardized, and we applied threshold-based detection, and then we identified the co-occurring anomalies as compound events, and then the spatial temporal analysis of the detected events were carried out. So in this case, we are not looking at what caused what. We are looking at the detection of these events, and the focus is on the use of anomalies so as to reduce data set biases and to be able to, we use the threshold so as to be able to compare effectively across the various climatic zones. And the occurrence events were carried out. So this figure depicts or shows us that we are having a higher level, a higher trend of a higher variability, a higher trend of the variability of temperature, standardized temperature, while that of rainfall looks a bit kind of sinusoidal. That of moisture also is on the rise over time. And then looking at the spatial pattern of rainfall variability, the level of rainfall variability is more concentrated along the Guinea coast. We have the weaker variability towards the Sahel. And if we look at that of temperature, in contrast to that of rainfall, so we're having a higher level of temperature anomalies or variability along the Sudan Sahel belt, and it is weaker along the Guinea coast. And a clear spatial structure is being seen here, which we shall see also when we look at the heat drought events. And so when we look at the classified events based on the class of severity, so most of these compound events are within the moderate range, which is more of the soil rainfall. But considering the severe range, we are having more of the heat drought compound events. So we do not have the extreme, anyone in the extreme severity class yet, but that for the heat drought compound event is one that we actually need to take cognizance of. And so we consider the heat drought compound event. And it was noted that the spatial arrangement or the spatial structuring of the heat drought compound event is very similar to that of the temperature anomalies, which is focused in the Sudan Sahel region of West Africa. So while we have limited occurrence of this along the Guinea coast, it is not random. So it's not that we are having some random compound events happening at any place in West Africa, but it is more concentrated along the Sudan Sahel belt. And we now look at the temporal distribution of these severe events. And while we had a pocket of events between 1980 and 2015, we are having more of these severe events, these severe compound events from 2015 to date, which calls for a cause of concern. It's more like a concern and something we need to pay more attention to as these compound events are on the increase. And so we also look at, so the summary of this study is that, yes, while a lot of times studies just look at temperature time series, rainfall time series, or the trend of these climatic patterns, it's also important to look at the rate of increase of the anomalies or the variabilities. Which means that the climate is becoming more variable, temperature is becoming more variable. Soil moisture, the level of variability of soil moisture is on the rise. Okay. And then these events are not just random, as I said, they are spatially concentrated to especially some certain hotspots in West Africa, which is the Sudano-Sahelian belt of West Africa. So while we have moderate events, we are beginning to have severe events more than ever before. So we concluded by saying that yes, while we still have the challenge of ground-based observation network, and we're also already talking about machine learning and artificial intelligence, the use of satellite data is still very, very important in providing critical insights in detecting compound hazards. And we've said that compound hazard events are actually structured. And it's important to look at where we have the concentration of these compound events, especially when we talk about food security and vulnerability to water resources. And so we may not focus on heat drought events. There are several compound events, just one of it, but it is an encouragement to let us know that yes, compound events exist. We should not look at events in isolation. We should look at many compound events as possible. Thank you very much.
Okay, we can to have instruction from the chief, the local organizing committee chairman, that we have to go for big round. Those come back, continue with this thing.
Just a very short one. Not to pick your notch. Yesterday was local. Today is international. Yes, and so when you get there, thank you very much. And I want to announce that helping us to do the community will be led by Professor Ifebalogu, Director DRP-WACS. So, and all the rapporteurs, we work with this. Thank you very much as we move there. That will talk to also
Okay, good afternoon, everyone. It's been a great day and almost exhausted. But I'll not take much of your time. I'll do a little description here. After that, if there is time, I'll some demonstration. So, this is the title of my lecture. It's not a very big scientific study, so to say. But in the end, it will only lead to a policy recommendation for institutions and help and assistance to those who have not been yet. We'll be talking about big data, AI, machine learning, and several other things. Also asked about capacity building. Am I correct? Am I correct? Yeah. So, this title, these presentations to at least keep an eye on the situation of students and researchers at college, because it is just an ongoing project. Okay. So, right, this is what I'm going to be discussing. I'm just going to give you an overview. Then I'll give you all these things. So this what call it? QR is one of the resources used to get the preliminary information that we used to write to, for this presentation. So what we have seen so far is that rapid growth of environmental data sets offers opportunities for data-driven discovery. Nigerian higher education institutions face challenges in educational capacity and infrastructure. Am I correct or wrong? Am I right? Okay. So then Python-based automated workflows improve data analysis speed, accuracy, and reproducibility. Many of us here are using Python. Some may not, and many have not. Okay, so but if you are able to use Python, then you'll be able to achieve this stuff. Then embedding programming in education enhances computational thinking and research productivity. Anybody can put data into ChatGPT or Gemini or NMetS and all that and generate something. But how correct is that? Because you are not the one who did it yourself. Okay, so this is the reason why we are looking at this. So why this study? Climate and environmental data are expanding rapidly. Do you know that now we are migrating from 76 to 77? Yeah. Do you also know that Era 5 is already being phased out gradually? So many of you are using Era 5, Era 6 has started development from January this year. So, said? 5 minutes. Yeah, sorry. Yeah. So I don't have to tell you, but I just want you to see the basic and most important things that are. Okay. So Nigerian higher education institutes face a paradox. And what is that paradox? Abundant data, but limited capacity and violence. Okay. We have so much data, but resources are limited to analyze them. Then there's need for automation and computational training to address capacity gaps. So we assess computational skills and institutional support in Nigerian higher education institutions, develop a Python-based automated work in environmental data analytics. You are able to get the slide, click on that link to take you to that GitHub page and the automation that was done there. Actually, it was a source. You find the source in that link. Then propose strategies to enhance computational capacity for climate resilience. So what was the approach that we used? The approach was that we conducted a simple survey across Nigerian higher education institutes. Don't forget, I said the project is still in continuation. because as at the time we submitted the abstract, we had collected only 60. Okay, so but currently we have over 300 responses that were received across Nigeria. Okay, so and then we are still collecting. You will see the scan. If you are able to scan also and help you, that will help also give better output from the research. So I use Python in Google Colab automated data collection, cleaning, and analysis. Leverage cloud native architecture and libraries. It's what they call PanGu. Like we're talking about cloud computing, okay? We may not have the resources to compute, but there are free sources out there like PanGu and some other mature services that can give you access to computing. So it's not difficult anymore like it used to be before. Okay, so this is just part of the code that I use to automate the information. So automatically, any information that comes in, this code automatically gives me the overall computation, cleaning, and everything. That's why we call it computational. So it's very easy. You don't have to do anything. This code will only automate. It will pick link, it will pick the information from where the information is coming, and then it will run all the analysis, clean the data, and then give you out. So what did we find? We find that 82%, actually of the respondents value programming, but 15 of them use it, 15% use it regularly. Then 65% are beginners and have no programming experience at all. Then 60% reports a lack of institutional support, not because the institutions do not want to help, but because the facilities are not available. So we are looking for alternative means of bringing out results, viable, good results, publication standard results out of Nigeria particularly, okay? So that is the link again. You can scan, if you're able to scan from your phone and scan. It's just 9 questions, then you just fill it within 3 minutes. So you see that regional programming proficiency levels across some of the states that we considered, and then you will see that significant regional disparity in programming languages there, and then advanced proficiency is rare, with some at 100% level of proficiency. But most of the people who have that literacy are lecturers. And how did they learn that? They learned it by themselves, by their rigor and by their efforts. Okay, there is no institutional based by computational studies, especially in climate and environmental science. So I think this study will really help both beginners and advanced and intermediate learners to grow in this. Okay, so here also I want to see. Yeah, there we have those who agree. That that institutions are in support. You can see the statistics. There is these institutional barriers, and I think and I believe that this institution can support students by giving the learning environment. It may not be that the infrastructure may be many, will be much, but with collaborations with people around, there are ways we can go through this and still do something very viable. Okay. So, because of time, high awareness but low implementation of programming in Nigerian higher education institutes, then limited infrastructure and training hinder computational capacity. Python-based automation can bridge the gap between data availability and analytic capability. During my PhD, I used more than 60 terabytes of data. Okay, so how do you manage 60 terabytes of data, especially over hundreds of years? How do you manage that with your little laptop? Okay, so Python offers you that flexibility. And there are cloud storage. For example, I have a storage of 2 terabytes on my Google Cloud. Okay, I don't have to carry my laptop to do anything. I do my coding, everything from that. Okay. So, and other resources for institutions, Google are given 1 year free of access. Okay, but many institutions are not aware of this, and they are not, helping their students to make use of that opportunity. So they're giving you free access. Just log in with your institutional ID, and then you can have storage. Okay. Then there is this WIQ also. How many of you have heard of WIQ? So WeCube also contains a cloud-based computational access. You can get anything. It will give you, large computational power, RAM and access and storage. Okay, with that you can do your computations, standard computations, and you can receive help to achieve your goals. So in conclusion, Python automation enhances environmental data analysis and resource constraint. HIS computational training is essential for evidence-based policy and policy making. Most times our research is not evidence-based. We don't really think because of lack of computational ability. Okay, so that will help us. So the future work is to expand this survey sample size, more robust insight. Okay, already now we have data across parts of the country, all space categories presented, and time will not allow me to show you that. If you want me to show the data, that is possible. Okay, so thank you very much. Can I just let's contribute to the problem. Thank you.
It's all wrong through.
Okay.
The rapporteur that has abandoned it.
First, what I think what you will do. Little bit so.
Yeah, I do remove that blocking. So, okay, that's not. It's okay.
Okay, the works on big data analytics and pattern dynamics and tropical discontinuity, durability, tropical West Africa. The next slide.
So,
This is the abstract of the work. As you can see from the abstract, mostly the harmattan, it usually carries northeast trade wind, and it comes with a lot of dust and humidity, intensity, and spatial influence are also be considered. So what we did, we developed a harmattan intensity index from the current work. The results indicate increasing fluctuations in the harmattan intensity index, and then the position of the ITD has shifted slightly. That is why this very, if you notice, the harmattan, there were a lot of anomalies, and it's very weak. This is the general introduction. This is the study area which covers West Africa. Then, but majorly, harmattan has regularly reduced horizontal visibility. In area to less than 1 kilometer in major cities, include Kano, Accra, Lagos. These cities, they were mostly affected whenever there is anomalies in harmattan. So the sources for the data processing, every data was prioritized into a single time scale and spatial grid. These are the analytical methods. This is the equation that was used, the analysis.
mean not easily with speed in meters per second. Then Sahara surface pressure is the Gulf of Guinea surface pressure, their relative humidity and normalized aerosol's optical depth. This is for the Harmattan intensity index. It's computed in this way. It's the equations. And below here are the interpretations of the HII. Okay, then these are those transport equations where the U stands for wind speed vector. And you know, wind sometimes it plays a very component role in the Harmattan anomaly, because once the directions of the wind changes, a lot of things will likely change, even the movement of the dust particles. So, and then the GIS and big data processing. All that I said, we agreed to 0.25 degree and harmonized temporarily using GIS. Statistical analysis that was used for this very well. Linear regression was done for the HII, that is Harmattan index versus intertropical continuity, latitude and dry season rainfall. And these are the results. The results indicate increasing fluctuation in the Harmattan intensity index, episodic weakening of dry season circulation, and notable excursion of ITD, associated with enhanced moisture transport. So from the figure here is the intertropical discontinuity mid-latitude during season from 1981 to 2023. And this is the relationship where the regression was used between Harmattan intensity index and those mass flux over the West Africa. This is the spatial distribution of the Harmattan intensity index across West Africa. These are the figure 5 is for the Harmattan dust transport pathway derived from wind vectors. You can see they are moving this direction. Recommendation and implication. It is recommended that meteorological agencies and climate research institutes to adapt big data. This issue of big data and AI, it has come to stay. It has come to stay. So sometimes when I had people complaining that NMetS refused to give data, if you know how to use big data and AI, you can still access NMetS data. Maybe it's closing gap you will go for. This is something one cannot say it officially. But with the use of AI and big data, when you prompt it well, you will get the existing data of NMetS, any agency that is in existence. So what you need is to get the closing gap, maybe 3 or 4 years. When you go and they tell you 5 million, you're able to prompt the AI or the big data and you get the yes. Let's say the yes stops at 2020. All you need to do, you go with your letter. Okay, I need data from 2023 to 2025. Maybe they will tell you pay 20,000. So what you will do if the data you got from AI or the big data stops at say 2021, if you are writing to NMetS, you tell them, okay, I need data from 2020 to 2025. So when they give you from 2020, you will now relate the data they give you with the one from the big data or big data or from the AI you prompted. Then you let them. If they give you the same information, you should know that the data is what? Genuine. Then you continue with your work. Because one thing with this big data and then the AI, any information that gets across into any of the website, the data can be harnessed. It has the ability to harness the data, to regenerate the data and give you real-time information. So the fact is this, big data, AI, they have come to stay. All we need to do is to learn how to use them. But we need to know something. These conventional ways of taking records, we have to maintain them continuously because we are not paying for the AI. It's only the data, our data that is being used. The big data, we're not paying for it. It's only the little data they receive from us. By the time we put all our forces in those areas, One day they will say, okay, if you want to log in, you must pay so amount. The money we refuse to give NMetS, we pay it online. So the conventional method of taking records should also be seriously maintained and preserved. So that by the time you log in and you're unable to get it from there, go back to your former ways of getting data. So that is just something.
Okay, so okay, thank you very much.
Thank you very much. Please, can you come to the
Let's go. Are you
Okay. So the next presentation is by by Hillary. Yeah.
Sorry. Well, you have to wait because I got to ask for not to wait. What? Nobody. Should I send see them like I'm not. Oh, who started to use that? More. You guys. Right. We sit here. You know, you still have to eat it. From that is okay. Okay. Follow me. This will be the story. Here.
Good afternoon. Dr. Saras.
Now.
I'm happy to be in this place. This is my name is Hillary Wavdige, and I working currently on the impact of climate change on construction projects in the Tulsa. This is the outline. So this is the introduction. The construction industry is a pusher to Nigeria's economy, providing infrastructure and improving living conditions. However, climate change poses significant changes affecting projects, delivery, and sustainability. Consequently, this leads to increased cost, delay, and safety risk by Ajayi et al. 2023. And consequently, issues related to climate change are now being taken more seriously due to their devastating effects on the environment and its inhabitants. Dudley et al. 2020, the Vija Van Hatta Roman et al. 2022. So climate change impacts construction projects through their life cycles, from planning to execution, affecting site selections, material performance, and worker productivity by Glean and happened in 2012. So the authors highlighted that climate change is expected to impact various aspects of project performance, given the long lifespan of construction projects. In a subsequent work by Kameli et al. 2020, reported on the possibility of climate change affecting construction projects, particularly aspects of project performance. So they stress the importance of analyzing and evaluating the potential impact of climate change on construction projects to take appropriate actions and ensure success in the construction industry. This study, therefore, aims to identify the impact of climate change on construction projects in Tulsa, Lagos, Nigeria, focusing on temperature change, rainfall patterns, and extreme weather events. The aim of this project is to identify the potential impact of climate change on construction projects in a chosen local government. The specific objective, though this particular research work is focused because of this, for the sake of this conference on the qualitative aspects, of data presentation, because further study of this also is considering the quantitative aspect of the data, to be applied to this work. But for the sake of this conference, we are majorly focusing on the qualitative aspect of this. And that's one for the additional work that we are doing on this work is on the specific objective 1. So, but for the sake of this conference, we are focusing from 2, identifying the influence of temperature change, rainfall, and extreme weather events, and so on. Then the last one is also to assess the level of awareness of construction professionals and stakeholders in a TIOSA regarding climate-related risks. The study area is, I said before, is a TIOSA. A TIOSA is a local government area in Lagos State, Nigeria, covering about 174.06 kilometers square. It's bounded by Lagos Lagoon North and the Atlantic Ocean South, with 3 council areas, TIOSA East, LCA, and Ikoyi Obalende, and the rural Victoria LCA. So the area experiences heavy rainfall between 1,800 to 2,200 annually, high temperature, averagely 20, and humidity, and so on. So the research designs utilizing structured questionnaires and interview method to collect data, such structured questionnaires, such response opinions and suggestions on the impact of climate change on construction industry. The sample size, the actual sample size to be used in this study was determined using cohort samples formula as follows. This is the study area showing all related by the legends. You can see it. It's the formula to determine the sample size. So because of errors, we rounded to 300 in order to cater for sampling error. And the adjusted sample size was 310. So these are the tables, from respondents, from this work, the percentage and the number of respondents and all that we analyzed. So this is another table also showing this table that is covering it. Then the table 1 above, shows that these results indicate that temperature fluctuations significantly impact construction activities in TIOSA, particularly in terms of project objective, planning team allocation, and the long-term maintenance, supporting the need for climate awareness, construction management strategies, including scheduling adjustment, use of temperature resistance, the adaptive workforce planning. 3. So, but I will talk about it. This also notably conflict between supplier, subcontractors, and contractors due to rainfall recorded a high mean of 3.0, ranking number 3 using the liter type, 5 liter type process, implying that rainfall is less frequently perceived as stakeholders dispute. So it indirectly will contribute to project delivery. This is table 4. Table 3 above, but I will just talk about the findings. These findings demonstrate that extreme weather events moderately influence construction activities in TIOSA, particularly in planning, workforce allocation, post-construction maintenance, and project activity. This emphasizes the need for adaptive construction strategies, such as contingency plan, weather resilient materials, and enhanced risk management to meet disruption caused by extreme weather. A percentage of 50.06 in the support of people. Table 4 talks about, I'll give the last list, that these results indicate that temperature change has a moderate but consistent impact on planning and design decisions, particularly in terms of material selections, considerations, design adjustment, and cost management. This underscore the importance of integrating climate resilience strategies and temperature adapted design measures into the early phase of construction projects to minimize future risk and ensure project sustainability. This is table 5. The findings suggest that rainfall significantly affect planning and design decisions, particularly in terms of selection, structural integrity, cost concentration. These underscore the necessity of integrating rainfall resilience strategy into the early stage of construction projects to ensure sustainability, safety, and long-term project success. This is the 6. So impact. Table 6 shows survey results and how extreme weather events affect the planning, design of construction projects in a TOSA local government area. Respondents assess 9 items using a 5-point Likert scale ranging from strongly agreed to strongly disagreed. So the overall mean score was 2.2 with an average rank of 2, indicating that extreme weather is moderately influenced on planning and design activity. Overall, the findings suggest extreme weather events moderately influence the planning design phase, especially in terms of structural safety, material selection, design techniques, and financial risk management. This underscores the importance of integrating adaptive strategy to climate resilient design measures in the early stage of construction projects to mitigate the effect of extreme weather and enhance project sustainability. From the survey, a total of 86.86 respondents are in agreement of the impact of climate change on industrial construction of the TOSA local government area. The construction industry must invest in continuous training scheme to make workers and management of the industry well aware of climate change impact by integrating climate change into the curriculum of workers, engineers, and planners. The industry can have an educated workforce and people well to face issues arising out of temperature, fluctuation, rainfall, and intense weather conditions. These are the references that was used. Thank you for listening. God bless you.
Thank you. So the answers that we're getting here is okay. La put it down. That we now starting to accept. Those who are making publications happen. Have you heard of the posters? Yeah, what was that? So after this, like I must see you. Still apologize.
Good afternoon, everybody. I'm starting on the existing protocol. I am Ilo Ikuhamaka, working on the project. On the slide, the application. Application of meteorological information on the production of maize, okra, and living green in Uli, here local government in Anambra State. And this work was done with the help of Professor Oyebune. Going forward,
Yes. Oh, you click on just slide.
okay, in the introduction, I said that this research highlights the relevance of rainfall agriculture in Uli, challenges from climate variability, and the importance of weather data for crop production. And we all know that agriculture remains a primary driver of Nigerian rural economy and plays a significant role in ensuring food security, employment, and income generation. One of the biggest environmental challenges bedeviling mankind is this 21st century is weather across the globe. The magnitude of impact of the phenomenon cannot be underestimated, as it has the propensity to affect the output of most agricultural crops, including vegetables. And this is the objective of my study. Say that the main objective is to assess the importance and application of meteorological information in maize, okra, and living green production in Uli. And this is also to determine the farmers' awareness and access to meteorological information, also examine visualization in agricultural planning, as planning, irrigation, harvesting, and decision making. It is also to identify challenges in assessing and using weather information, and also assesses the importance of meteorological information on production outcome. And this is the background. The study, this is my study area. This is a map of Uli. And it's located in Ihia local government, where the study was carried out. Now, my problem statement is climate change reduces crop yield, farmers lack access to recast, and low understanding and trust. Now, the gap of this study is that inadequate local observing networks and generic forecasts, poor translation into farm practices, and weak extension support and low trust. Now, this sample was carried out. The design is a descriptive survey suitable for analyzing perceptions and impact of weather info on farming. And the area is Suli, and the population of the study I use is 300, which is the number of registered farmers. I use a YAML formula 1967 to determine the sample size, and also I used descriptive and inferential statistics to analyze my work, and the inferential statistics is nice, which at the end of the day this is the discussion of results. We say that analysis of age range of farmers say that the dominance of middle-aged farmers reflects strong participation by individuals in their prime working years, with minimal engagement from the elderly and youth. From the elderly, the farming population is diverse, active, and increasingly weather aware, yet needs support in assessing and interpreting meteorological information for multiple crops. Now, the years of practice, you find out that, looking at the chart, you find out that most of them, because they are youth, their years of practice is not that really that much. You find out that most of them fall at the age of 5 years of practice. And the access and awareness of weather information, you see that their access is moderate to inconsistent, limiting effective day-to-day farm planning. While digital access is growing, radio, TV, and farmers' network remain essential. And most farmers find forecasts applicable to their local farms. And at the same time, there is high perceived relevance support which supports better decision making and planning. Farmers are aware and receptive to weather information. Digital platforms promise but must be scaled equitably, which need for more consistent, localized, and actionable forecasts. Now, looking at the application, that over half of farmers are adopting climate smart practices. Those not stating the lack interpretation skills, like the people that are not changing to this smart agriculture are the people that don't understand the interpretation of the data they acquire. And at the same time, the major issues are accessibility. the timing and interpretation, even really reliable information is underused without clear delivery and support. Moving forward, we said that majority are growing in competence with focus. A significant minority needs for technical information. Meteorological data supports climate smart farming decision, improving access and training will boost productivity and resilience. By clear demand for localized and actionable weather info, reinforces the need for investment in climate service and farmers' education. Now, looking at the support preferences and recommendation,
Are you sending for
the type of weather information value at the farmers, there is high demand for actionable, targeted forecasts. Farmers want help with planting, pest control, and climatic adaptation information. Now, preferred delivery as support system. We'll talk about this. Farmers need digital tools, but training and connectivity are essential for effective use, because you cannot have tools that you don't know how to use. And first of all, you have to know what you're going to use it to do, even if it's not there, so that whenever it comes, you'll be able to operate it. The next one is institutional expectation from farmers. We're talking about the support farmers need. Near unanimous calls for more institutional involved in forecast delivery. Farmers support infrastructure and extension services. Now, utilization, see that meteorological information are used in planting decisions, harvest planning, pest and disease control, crop variety selection, irrigation scheduling, less common, and the high frequency of use when information is available. Now, this is the importance of meteorological information. The challenges faced by farmers in Uli, you see that there are 68.3% limited access and limited delivery of forecasts. Now, there is difficulty in interpretation and low trust in accuracy. Even if I have the information, I don't know how accurate it is. And the next one is confidence in interpretation. Now, it is somehow low. Some people might be seeing, maybe they see 23 degrees Celsius, but they don't know that it's that atmospheric temperature. They don't know what it's all about. What they know is that there is something popping up in their phone. So for my conclusion, I will say that meteorological information is crucial for agricultural decision making, planning, and risk management. It is utility depends on access, trust, and interpretation. For me to use the information, I will have to have access. I will have to trust the source. And at the same time, I will be able to interpret it. Because if I have data that I cannot interpret, it doesn't make sense. That means the data is not utilized. Next one is strengthening digital information, infrastructure, and training. Key for future resilience. This is where we talk about training for climate resilience, which involve cloud computing and data sharing to enable the integration of satellite information into farming and all the rest. Then, the majority of farmers are adopting forecast into operation, yes. And you see, when you follow the meteorological information given to you, you find out that when you're supposed to plant today, and you find out that the rain is going to fall next tomorrow, you wait for the rain to soften the land for you to cultivate first. And next one is, however, food benefits are limited by assets, literacy, and institutional gaps. Frequency of information access influences trust and usage. And usage of meteorological information is linked to yield perception. Now, when you use the information, that's when you know you have the results you want. Now, here is my recommendation for the support and for strengthening farmers in Uli. Say that expand forecast access and timeliness by NMetS,
okay,
FRI.
Yeah.
And these are the institutions that we need support from. That NMetS should focus more, get more outlets where people can be able to trust their data and be able to access it and the rest. And these are my suggestions for further studies. Thank you very much.
Thank you. Thank you.
Yes.
Okay, so we will take brief questions
because of who's online. Please, are you still there? Oh, Dr. Steve. Dr. Please, Dr. Steve.
Yes, I'm listening.
Oh, that's great.
That's great.
So, what?
Yeah. Well, the ones that presented now. One of them. Yeah.
Then,
we can start the question with I will ask Professor Kone.
Yes.
I want to ask a question of the.
You don't necessarily have to answer.
Yeah. You can see
to ask. At the exception of WACS.
One of my students did
boundary layer studies.
And
WACS had the stations in
Pangana.
Yeah.
Are there stations still open? Oh, at that time, I think
WACS was planning to extend,
you know. Yeah, the Burkina Faso on was there then at Bogatanga.
Yeah. Yeah. Now they're happening to myself.
Are we hope in Nigeria?
I don't know for myself. But they are like it.
Okay.
All
right.
Enjoy. What? How you want how do you based on that? Yes, there's two one in Nigeria. One.
Okay.
That's good. And you know, some of these institutions, that's good. Well, compared to what they come.
Thank you.
So, any questions? What questions for the presenter?
Yes. Which of them? Okay.
Good afternoon, everyone. Good afternoon. So I just want to ask, I don't know, maybe you said it and I missed it, but from your topic, the application of methodological information, you mentioned the list of crops and the study area. So I wanted to ask, or I want to ask rather, is there a reason why you are working with those specific crops? And then the specific area you picked. So is there a reason why you picked that specific study area? And then also you talked about applying methodological information. Have there been cases where methodological information have not been applied, and how has the output been in that same area? So
yeah, do you get questions? I will be okay, so I'll answer. So let me add to what's I'm asking. This survey is a survey. That's all that meditation. Because you mentioned crops. Did you plant? Did you?
Yeah.
And you did the phenological studies? Or just yield from your own yield? Okay. All right. So that we are talking about the farmers' capacity to use meteorological information. Did you interact with what they call extension workers. You find out how they interact with the farmers. And then even the extension workers themselves. I had a PhD student many years ago who worked on the information needs of farmers. And in about how many local governments? Sorry, in 3 states, Western Nigeria. So in Western, he went to so many of those farmers. He went to the extension workers that are in those areas, find out the interaction with them and the farmers. To also find out the farmers' use of their local knowledge on information, on weather information, and then integrate. So it's a lot of you do that, or it's part of what we are going to do in your further study. Should you answer later? Okay, you answer later. Okay, any other question for somebody else? They are taking the questions.
Let's not go to the results. When you were presenting your results, you said Ikorodu has the highest because it is north of Lagos. Probably because of that, they were characterized with northeasterlies. So my question is, at what month did you record the highest pollution? And secondly, did you look at the streamline?
No, wait.
Okay, you say no. You will tell you. Say you mentioned that Ikorodu.
Okay, the first question: at what month that Ikorodu recorded the highest pollution? And secondly, did you look at the streamline over Lagos to know the trajectory of the wind before you come to that conclusion?
Okay, my question goes to the man that talked about construction and climate change. So I want to find out, you said your respondents were from Ethiopia local government. Now, your respondents who are from Ethiopia local government, are they random respondents or they have something to do with construction and they have adequate knowledge about how climate change affects construction? For example, now I'm a finance guy in a project, and you come to ask me about how extreme temperature is affecting construction. I may not be able to answer you because I have no idea about climate change. All I know is money and the output. So how did you now come to conclusion using the responses without the biases?
So,
Thank you very much for your really wonderful. I can go to the one that talked about the climate change station. Show the impact that climate change and I like that they appropriate actually material to overcome the issue. Do you have some examples of material that now we can use that can resist the impacts of climate change?
Yeah, I'm going to ask a question. Okay. My question goes to, yes, Mr. Planner. Your work title talks about impact of climate change on construction projects. But what you told us about was weather extremes. Climate change and weather extremes, not the same. If you have a weather hazard, that may not necessarily mean that it's climate change. So it's something we may need to look at again. Because if you talk about climate change, by definition, climate change is quite different from looking at these singular events. So we need to look at that. And then to Madam Oluwabukola. Yes, the concern she raised, I also noted it down that we should be careful, or you should be careful on the conclusions you make based on locations. There are so many other factors that may have caused a higher level of concentration of pollution, especially the PM2.5 and PM10 in Ikorodu. It may be due to population density. It may be due to vehicular density. It may be due to the situation of industries, or maybe we have some dump sites over there. It will be good if there can be a location visit. Okay, you visit the site visit, and then you carry out some studies or ground studies also to now know why. Because if you say because of it is north of Lagos, that will make some very serious and northeasterners, that will be some that will make some plans. So I think there's a question. Yeah, I want to read that question for Oluwabukola again. Good day, everyone. Let me see if I can. This is from the Infinix. We don't know the name. Please, my question is for the last speaker. What authority validated her statement that PM2.5 is the cause of many deaths yearly in Nigeria? So, after that.
Thank you very much. To the lady who presented on air quality, the results showed annual variability, but your data was for 4 months. So how did you come about that annual report? And it was just 24 hours annual. So that was also, you talked about the boundary layer, but you didn't take any wind data, wind speed, wind direction. Your data set did not include that. But how did you know that it was stagnant there? Because if there's high wind speed, it might be not from Ikorodu, but from other places that came to speed there. So you have to check all those things, the wind speed, the direction with the boundary layer conditions. Thank you.
I think that last question is okay.
I think service coming up for question.
Yes.
Not over question. See?
What? Yes, I'm
coming up. Because I just want to appreciate Dr. Dongo for the work he's doing, but and he's asking us to join the project. But what exactly is the project about? The sponsors, the extent you have mapped it across the country, and we have seen you on the platform. Nigerian Meteorological Society inviting people to be trained on Python, on internet, and so many things. We really appreciate it. It's the kind of thing that we should be doing, particularly for the young ones in AI and all that. We appreciate it, but we need to know more about it. What project is it? Is it internally funded or internationally funded? And how is it going? Are you alone or is it partnership? So that way you will be able to appreciate it more, see what value can come out of it. Thank you. I wanted to ask him a question, but it's still coming up.
Okay. No, it's one of the presenters. So I asked him so that I will.
Okay. Thank you. He talked about the compound events, the issue of compound events. But as he was talking about the compound events, you know, we have issues, humidity, temperature, heat, rainfall, extremes. And he talked about it, but he was talking about it. I looked at what it did during this period, more so because one thing we're not doing, and that's something we should watch, is that we're not going enough. Tomorrow, when we talk at the AGM, we're going to talk more about because I'm doing some analysis of data. Many of us are just in core meteorology. We are not interlinking, overlapping with social sciences. So when we bring social sciences, how has this over the years impacted on migration over the hinterlands, over the Sahel, over Mali, over all these places? Is it because of the eventuality? What we are seeing now as banditry, I like to call it terrorism. I mean, what is the link? Maybe it is not yet instantaneous correlation. But if we leave a data gap, all of these things happening across the head, is it driving migration? And can it explain what is happening so that when we look at climate change, and thank God for Sokones here, what drives force? I teach my students about the control, that is the triggering, then the mechanism that sustains it, and then traffic completeness. So these are all linked. I want you to expand your compound event system to meteorological forecast and event management when it comes to social responsibilities. Thank you, sir.
So before you give your answer, one of the things also presenters at conferences like this, so notes. Biru is not here. Biru at your presentation is not good in terms of the slides. You know, if you go to the international conference and in the majority departments in Fulta, that's what we make a distinction between PowerPoint and Power Notes. Power Notes take the thing that you have in your MS Word and put it like that. PowerPoint has to be sharp and things you speak to and things like that. So in some conferences, especially if it has to do with competitions, people score that. And they take that. Somebody sitting back should be able to see what they are presenting, you know, and be able to relate to. And then also the arrangements for the arrangements should be sequential, you know, and people will follow, you know, your thoughts. So now you will now answer the question. But who am I starting with? Anyway, please. Anyway, Chiamaka has already started. Maybe the other one.
The question said that from a lady over here, she said, why do I pick the crops, the vegetable I need? Now, looking at the markets, yes, it is not, mostly we believe that all those vegetables come from the north. But to an extent, we at the east, we are trying to make up what we can. So looking at what we have, found out that I personally, okay, let me answer one indirectly. You said why I picked this specific location. I'm from there. And as a graduate that I am, coming from that village, I don't know anything about meteorology until I got the appointment as a staff. And even when they ask you where you're working, you say they are working at this place. They say, is it the people that's meteorological, this thing? No, you start explaining. To an extent, they don't have the idea that this is what this is all about. So individually and collectively, I took it upon myself to say, if I can actually know whether these people know that also meteorology is all about, is among weather forecasts, then you can also use it to enhance your farming. Now, the crop that you ask, it is really, the production, the yield is really minimal in that area. I said, let me know. If they know, if they have the idea of this information, can it actually increase the yield? I don't know if I answered your question.
Yeah.
Okay, from my prof, the meeting again on this same topic. So you said if I had an interaction with the extension workers, number one is that the extension workers we have, in fact, I'm not sure if there's any outpost of there is not any force of extension worker. When you will see them now is towards the state capitals. That's why I'm reckoning on the support. They don't even have, there are people to work, but there is nobody to tell them that this is what you will do. So most of them, they based on the knowledge they think they have. Now, farming with the local knowledge that we have is what really is helping us. But looking at the information from the forecasting, it's not really, we are not into it. So that's one of the reasons I said, let me go. I don't know if I really make.
Yeah, but extension workers, where do you look for them?
No, there are.
No, where you want to look for them in the local government? Where do you go?
There is a, what is this is calling?
Because you are saying that many of them are
mostly
voters, because they are there in every local government. They have, if you go to the local government office, the agricultural department, they have them.
The thing is that they are not active.
Okay. Then that's what then yeah, you should shut up. You should part of the reports.
It's not as if they should help. From my conclusion and their recommendation, I made something like that.
Okay. So what you do is that if that's not back of methodology, you can say that you had in the class and you try to find out some of this or or what your experience will follow you.
And even the farmers would have. Did you do questionnaire? Yeah, part of your questionnaire is to find out whether they know anything about
the knowledge. That's where you see that
know any extension work.
I did ask that in my questionnaire, but the awareness of the information was asked.
Yeah, it would be good if it is possible.
Yeah, because the extension workers are actually ones to explain these things, the information, how to use the information on climate issue.
And again, the extension workers, they need training.
Yeah,
they don't have the information.
You interact with them to know even how much they know about the climate information.
All right, no problem. Thank you, sir.
Thank you. Questions on whether we strategically selected pre-professional in this. You cannot go and ask the wheelbarrow pusher that what are the part of, do you believe that temperature and rainfall affects consumption stream? Because over half of my life, I have been in the construction industry, and we targeted because I had a lot of people, engineers. I am a foundation expert. I do soil investigations and deep foundation construction. So I met a couple of engineers, structural builders, and the rest of them. So I had to send, the questionnaires to them, and they were able to respond. And we targeted about a sample size about 310, and at the end of the day, we didn't give anybody who is not within the industry. And this research work is not only centered on the qualitative, it's also centered on the quantitative. And I was able to get data from NMetS for 30 years to add to the data, because it's separate, it's like a two-way separate, what's it called, interpretation of the result, based one on questionnaire, two based that for NMetS for 30 years for the area. And that's what we have done. And to his question that he asked, whether we are, that based on the impact of climate change, is there anything that we are recommending that, of course, that will be able to withstand the impact of, climate on part of the building materials and all that? Our recommendations are based on the fact that we should be able to get the quality material that have resistance to climate change. And also, we are encouraging producers and manufacturers to try as much as possible to increase the strength of material or whatever that they are doing, even in terms of paint and all that, that you should be able to at least do quality quality being that to be able to last over time. That of course we have water resistant and sunshine impact to these materials. That's exactly. I think the third one, it was somebody asked a question. So it was because of this, was blocking it. We have about 16 tables from questionnaires discussing on temperature, rainfall, which are the most important data I got from NMetS. Temperature and rainfall data, because they are the things I had to use with regression, doing another, and then Python is also used. Python software is also used to, have our graph and, iterate more on it. That is
but the changes what were very significant among all the parameters.
Yeah, it was temperature that was showing. Because there's temperature data that was derived, and there's a table in my full work that also show the average temperature yearly about 30 years, and also total sunshine and humidity were also calculated in the table, which was Python was used to analyze, and then graphs were very low. But the major recommended parameter were from my supervisors were temperature and rain for 30 years.
So we have to be a bit careful with the statements.
Yes, of course.
Making. Coming back to the question, the young lady, yes.
I've already answered.
Yes, back to it. He wanted to know from your investigation, did you find out any material that is impacted by climate? And then what? It's not just a general statement. But
has caused a lot of damage to some of the materials.
Specific. We are talking about changing the material. So if you are going to be talking about this material is not resistant, this is resistant. What, for instance, now you know that the Minister of Works is doing concrete roads and things like that. Have you tried to ask why? Why is he doing that kind of thing? Now, the asphalt that we use, does it have any, to do roads construction?
This is affected by temperature.
Affected by temperature. Those are the type of things that one expects that a study that is here should be in empirical, should say that this is how it affects, at a point, Dangote, I think, was that started, with one road. So excavate, and then even excavate the soil. This anything about the soil.
What I would suggest, sir, is that you're a construction engineer, right? So going forward, please collaborate with a climatologist or a climate scientist or a meteorologist.
My supervisor is Dr. Yagi is a meteorologist.
Yeah, and a meteorologist, so that you can have broader or a better scope, a better foundation towards, because we are thinking as meteorologists, she's a climatologist, so a construction engineer. There's nothing wrong if you now have a very approach. And with that, we have a better outcome. Because if you ask us, if you ask from us now, there are some other dimensions, ideas that we introduce to make this work a very, very solid. If you present it to building and construction engineers, the way they will look at it, they will perceive it, will be different from the way we are passing it. So we are giving this perception based on our background and our discipline. I hope you understand now.
Okay, any other? Okay, let's.
Thank you very much, everyone, for your observations.
If you have finished yours, maybe.
No, not take pictures.
Oh, no, they can sit down. When we are taking pictures, you come out. I will not be punishing you.
So study, I know there's more work that the study focused primarily on the meteorological influence on PM2 variation across Lagos. So for further study, we do some source apportionment, look at other details I mentioned. Then I would like to answer the questions she asked. She said only data from October 27. So it's not annually.
For results and annual results
I'm not sure you saw annual.
Yeah, I was right here. So there was 24 hours, there was annual. So that should, you should have the data with 24 hours, right? 24 hours. I wish your slides could be shown to see what I saw.
So we have diagram.
Was diagram of 24 and it was annual plots.
So if you had seen annual,
sorry, no, but there were two contacts. So where you see your own plot. I was privileged to have the screen here.
No, we are finished. We're
even training to see your results.
In fact, we can down. Maybe the access to them.
So even that's why maybe I might see something else and you might be seeing something else. So please, it was too compact.
That's noted. So
President.
Once the next person, you asked that what's the month that has the highest pollution level in Ikorodu? And the answer is December. Then
so why?
Please. Hello, see your annual on the top. Hope you get my point.
Oh, yeah. So if that's what I was trying to say, that if we saw annual, then it was supposed to be either monthly. Yeah.
So you get my point that it was annual in 24 hours. So I was confused to why there was annual. It was only 4 months data.
That's it. That's seen it on the.
But they can't see.
That's
not.
But looking like it of the
So I hope I've answered you.
No, I just had it.
I mentioned earlier that we're going to for that work and that.
That's why you're and that part of them why they have bias. My systems carry a similar analysis over the walking it's trajectory weight, because one, if through the analysis, if you over that is okay. When you are having not studies, you understand? But if you over there have calm winds. So any suspension that's reset. There's no the wind speed is not that high. So that is why I'm asking if there is analysis, what kind of winds experience.
Said they will do that.
They didn't.
Yeah, so we didn't do that.
There's no wind direction.
No, you cannot.
Yes, so that's why I said we have to do source for precaution.
Yes.
Yes, thank you for that observation. That is well noted. Then the last question, the question from the online participant. So I made a comment from the Global State of Air Quality report that is usually published annually by Epic Air. Epic Air is situated in University of Chicago, and they are responsible for giving global data regarding air quality. And I don't know if you saw it, in that same report, it was stated that Nigeria has the least life expectancy in the world. We have 196 countries in the world, and Nigeria tops that list. So breaking down information down further, they identified factors that is responsible for that low life expectancy. And PM 2.5 was stated as the second reason for that. And Lagos also had some statistics. I think I read that about 52% or so die per day because of PM 2.5 injection related this. But I mean, I can't reference that, but I read that during the course of this. So PM 2.5 is responsible for that.
Thank you, Professor, for your contribution and comments. Sir, regarding the projects, for now, it's projects on. Okay. For now, the project is on very preliminary stage. So there needs to be some like preliminary investigation. Although there is somebody in FUTA that we actually start this project this last. So I went through an ML machine learning training with them, computer science department in FUTA. So it was from there the idea was generated. So, but for the funding, nothing yet. And we are still looking for collaborators. In fact, even from the north especially, and some central states are already declaring interest. But we now have to look at it holistically across the country, what is actually happening, so that we can have a broader view of countries' ability to use big data. Don't know it, heard about it, but the reports from publications and everything shows otherwise on our usage. These so and I've also attended a lot of trainings also in some of these big institutions that still say that Africans are not forthcoming. So these are some things that bring about this foundation. And then we want to see the sport that from the undergraduate level, students begin to have the idea of what these things mean. Not necessarily on a very big scale, but having the information that they can build upon so that in their master's and PhD levels, the research outcome will not be shallow. And they will be able to use some of these to do something for Africa, Nigeria particularly. So most of the results we see and research we see done to Africa, they're Nigerians or Africans doing it out there. Some of them from their degree into masters to PhD and then white men and do some research on that. Why? Because they have access to infrastructure. For us here, they need people on ground here who can assist and develop, upcoming scientists in this way. So we are still looking for collaborators. Nothing solid has really been done yet. So far, we have collected some relatively large sampling size that these people used to write some of these big organizations that assist enrolling this project. It may not be, for now, it may not be like an academic activity, but if the institutions themselves are ready, then they can collaborate such that even if it's 1 in a semester, 1 month in a semester, they just have this introductory session. Then they learn, and then the next semester again they learn. Next semester, if they don't once, then they can develop themselves from there. Pending the time, infrastructure will be available for all those institutions.
Thank you. Okay.
Thank you very much for your question. As many of my senior colleagues from FUTA would say that I will die, you think we don't know what you're doing. Yeah, so I did not know that Prof was very aware about my research, also. So I had my first and second geology after my PhD, which I had WASCAL footprint, which has to do with human climate change and human habitat. My focus was on climate and environment impacts on human migration. I also worked with the migrant web framework. I was one that worked with the migrant web framework. So that's to yeah. So as part of my preliminary studies, I remember in 2022 at the WACS conference at Burkina Faso, Ouagadougou, I presented on the influence. I did a systematic review on the influence of climate and the environment on the migration of small-scale farmers, especially in the Sudan Sahel region of Nigeria. And more than ever before, the influence is much more than what it used to be. Now, linking climatic and environmental studies to human migration, because human migration is a very social aspect. It's very complicated because right from history, humans, especially West Africans, are nomadic in nature. And if you consider those from the northern parts of West Africa especially, and based on their profession, they are basically pastoralists. So they are pastoral farming, and that will trigger their movement, or that will influence their movement from one location to the other. Now, based on my study, because the initial challenge was that due to the complexities, climate in many cases does not have that immediate or direct effect on human migration. It often influences or it affects their livelihoods. So when their livelihoods are affected, the farmer says that the climate here is no longer favorable. And I've tried to apply fertilizer, I've tried to use irrigation, it's no longer working. Let me go elsewhere and practice my farming activities. So that's the case. But in the southern parts of the region, it's quite different. In many cases, migration takes place due to, once again, the search for better source of living, better livelihoods, for job opportunities, business opportunities. A lot of people migrate for education reasons. Many migrate maybe due to marriage. Now, in recent times, we also have induced migration due to conflicts, insecurity. There is a situation happening in Jos right now. And one of my friends, in fact, reached out to me that there's a curfew going on, the 48-hour curfew. And once the curfew is lifted, they are looking for how they can move away from that place. Because it's been a long time they've had such instability in Jos. So it's quite complicated, the issue of conflicts and insecurity, then the issue of loss of livelihood. Then we also have hazards taking place also. And there's another component, which is component of resilience and the need for adaptation. So rather than trying to migrate or leave that particular location, they will try every means possible to adapt to the situation going on around that. Oh, well, so if they say that they have no other choice, then they migrate. So migration is often seen as the last option due to various reasons, maybe heritage or historical ties or cultural ties to that place. But that said, sir, you have a very, very good idea, which I'm going to consider, to look at, yes, you look at climate several times, but compound events also. It may be not just due to drought alone, it may be due to drought and livelihood. So we are going to combine the physical and the social aspects of that, and something that I would love to look into. Time that would be a document, to be a document like it.
Okay, let me say something on that. We discovered also that climate change, all for instance, the migration, not even migrating within Nigeria, migration from the northern part of Africa. Okay, what of say last has not left Nigeria. So any land anywhere involved is in Nigeria. So that's the governor of the current governor of Bauchi State. It's on the on YouTube. Now the implication of that is that because they are nomadic, like you said, now they are looking for pasture for their livestock. And then there's also a religious type that their progenitor or whatever has told them that West Africa or whatever that is their land given to them. So all this, match together and one thing they are not saying that North Africa where there's acute drought, but they are looking at where there is water and all that. So they now come here. It's actually what we call herdsmen farmers clash. It's go beyond that. The herdsmen live anywhere that they can thrive. It's their land. So get out. or you get out by that. And they say, either you negotiate or you die. That is the, so it's a permanent thing. Look at the Lake Chad region. It's shrinking and shrinking and shrinking. All the activities that happen there, not just the agricultural activities, the nomads that were there are moving out. And they are looking for where to go. So it's an intertwined social, climatic, religious, movement. Someone said, you allow me to see one fish. Yes, sir.
And that I want to make a comment on. Dr. Labin is not here. Some people have been talking so much about intensity of ITD. Intensity of ITD. I don't want that. No.
Okay, like you said that you are going to answer the question. I can't come down to answer the question. Say you will answer the question.
Let's say because of posterity. You know, it's important to treat a symptom and not the cause itself. I wanted to tell him that the research should go beyond just tracking ITD. We know ITD migrates and all this. When it goes up, we know what it does and so on. But anybody, the very careful relationship of ITD and the very drivers ITD. Drivers such like Alara heat low. You know the relationship between Alara heat low and ITD? But somebody told a compound strength, let me put that language, between the migration of when you're finding ITD and the jet streams, like AEW. I mean, let's look at the AEG, which is at the lower something. When AEG weakness, we have seen that it's good or when it intensifies something that then TEG is legit. Also, even the moisture. Have the teleconnection is and so on. These areas in the south, in the Pacific Ocean, they also influence. What about SSCs in the Gulf of Guinea? So all of these are compound somewhere. I would rather want also calibrate all other factors and not look at it one alone. We can say yes, this is the index. For example, if ITD can explain what happened during the last Hamatan, when the giants walked and it was strong in the south, in the north. All of them. Until we do that, that IITT not predict. And that's the issue. We go from control mechanism to prediction. So what can predict? All these factors. These are the things we should go into in meteorology so that we can begin to think about what we have in years to come.
Thank you, sir. Thanks. Okay, match two, come and take to John. Then we'll go. I think the poster who join us, the poster will present only one poster. Okay, take off the picture, then we'll go out and then anyone. How about the photographs? And that's what I'm going to put you. So come quickly. Those batch two presenters. We don't have anybody online. So what is am I doing?
Presented. Gender balance.
Is that the chief? That's part of the. Someone wants me to jump. I don't know whether I can jump this time. Okay, I can jump this. Thank you. Oh, you can't do it today. Oh, no. I'm okay. Sure. Okay, let's go to the what's last time?
I can move before, but
Let me go there and ask questions. So the what's that? I will play that. Come here. How long does it take tomorrow? Come back for announcement. But man, for something wrong. Announcement. Yeah. What then? The next yeah, come back. Yes. But the message. That place is all I know. Yeah. I think I know. I'm gonna get one.
a small mismatch, we can align it with the problem of calibration with the instrument. So for this particular day, we can say that we have dust in the planetary boundary layer, as you can see for the profile, and we have sulfide volcano in the marine boundary layer. So basically, that was the study that we do to try the different aerosol profile from the atmosphere. So this is actually a good mission for some that would like to understand the real impact of different particles in the atmosphere. So if we have more dust, how can it influence the climate? Or if we have more marine particles, how can it influence the climate? But we have some limitations with this method, because if we load more particles that are more than 3, it will be quite difficult to do the extraction, like to do the isolation of them. So we need to perform more. Maybe in that case, we can use DI2 to have more accuracy. So this is all about the study. Thank you very much.
Thank you for this to aerosol methodologies. But I just want to ask a simple question based on what I see. Okay. So these bands of what color is this? So what are these bands for? What are you trying to define?
Actually, it confines the period of the study, the period that we used to collect the data.
Your period of collecting data is from July to September.
Yes, but this actually, yes, this is what we did.
Funds from January to December.
Yes, this one we took the data from the whole year.
Okay.
But this band is just to say that this is the period that we collect the data, because the data that we do to do this is the
okay,
data.
2 data sets there.
Exactly.
Okay, you superimpose 2 data sets, and the first data set is from this instrument. The second data set is from this instrument. So I'm seeing black and red. Which one is for this instrument? Which one is for this instrument?
Here, all the data is from this instrument.
Okay.
But the black and red that we are saying is for 2 locations, Sile Island and Mindelo. But actually, the data of this instrument was taken in Mindelo, so we just focus on Mindelo.
Then your back trajectory, I'm seeing this is the 10, right?
Yes.
And this is the 24. I'm only seeing sort of intensification and the weakness, something happening there.
Can you be like clear? Intensification in terms of
the trajectory is about the same, right?
No, it depends on the type of air mass that we have and depend on the altitude. For example, here it is not so clear. We can see that from 100 meter, which type of aerosol comes from where?
What is the shaded one? Switch aerosol.
The shaded. This color determines the aerosol optical depth, actually. So it's
for all the ones you characterize.
Exactly. For all the type of particles that you can have in the atmosphere, depend on that marine particles for all. So it means that here we load more aerosol particle depth. Here we have the high values of aerosol particle depth.
Okay, so thank you. I'm not going to dwell only on these aerosol optical depths. Comparing this date and this date, what has happened?
We see that the values of the aerosol particle depth are decreased, because we know that from the uplift of the dust, they have a period, for example, from June to September.
So here, no, it is not the same period. This one is 10. It means that from 10 to 24, a lot of the aerosol cadets decrease.
But from the same trajectory, because I'm seeing.
Yes, this is the same level of atmosphere height.
Same locations, right?
Yes, both are the same locations. But different
What is your objective in essence?
Yes, is to do the profiling of the different aerosol types. During the campaign, like we have the atmosphere like this, which are the type of particles that we have, or that's normal and atmospheric layer.
The two instruments are they mounted on the same station?
Yes, at the same. So this one is on the roof of actually this building, and the second one is localized around somewhere around here. But this is the same location.
Okay, thank you. Very nice.
Thank you very much.
Okay, let's go back.
It's printing error. It's printing error.
Yes, printing is and the kind of material they use, they now want to use colored background. She's not supposed to use colored background again.
No, it depends on not stuff.
White background is the background.
All enjoy session and welcome as open work. Last mistake, we were able to give them some additional work, so we appreciate you. So the announcement is this: do we have anybody here who have not presented and he wants to present either online or who is here that has not presented? Nobody?
If you say so now, or whatever, hold your peace.
So the next announcement, all the rapporteur to work with Professor A. Oguleye. Yes, and is having an online meeting. So so work with Professor A. Oguleye so that we will come back here tomorrow with the community. Please, I want to suggest that. Please, Dr. Aweda, what is it you say together tonight? Yes.
Mr. Fadiru. So, yes, you know what it contains must be detailed. All the presentation, possibly even from yesterday, different years. Of course, yeah. Yes, even handle everything. So, okay. We did all the sessions together and we witnessed all these sessions. And these people being short are really low. In your day, yes, give technical support. Thank you very much. So find your technical support so that you know what happening is. They bring out if there's any missing because they were part of the presentation of the beginning with the hand. If there's anything that are not captured by I want to suggest that everything will be captured. So yes, the coordinator capable Professor the work starts now. Yes. Yes, the work starts now. Yes. And the next one is by 9 a.m. tomorrow. All registered members of yes. Can we make it earlier? If you are not coming from 8 o'clock, 9 a.m. is better. 9 a.m. there will be 8 p.m. here. Please, for registered members of Nigerian Technological Society, 9 a.m. We will not wait. I think it's in that 8 a.m. we will send the communique. Yes, sir. We make contributions and immediately we invite the press to present the report of this. And don't forget, we have every component of the recording in progress. Every component of a conference. We have the poster session, we have